All right. Hey, everyone. Welcome back. We are diving into the world of OpenAI, and more specifically, their embeddings.
Sounds exciting.
It is,
Yeah.
but I know it can feel a little overwhelming, especially for those of you who are, say, 3 months into your Python journey.
Oh, yeah, definitely. Documentation can be dense.
For sure. So think of this deep dive as your cheat sheet to OpenAI's embeddings.
Love it. A roadmap before you even open the official docs.
Exactly. And to guide us through this, we have our expert, ready to demystify embeddings.
Absolutely, let's do it.
Perfect. Okay, so first things first. In the simplest terms, what is an embedding?
Well, imagine you're trying to explain happiness to a computer.
Oh,
You can't just feed it the word happy, right? It needs something more concrete, more mathematical.
right. Computers love their numbers.
Exactly. And that's where these embeddings come in. It's like translating, I don't know, emotions or even whole chunks of text into a language. Computers get numbers.
So instead of happy, we're giving it a numerical representation of what happy means.
Precisely. And these numbers, they're not just random, they're carefully calculated. They represent relationships between words, like are they similar, opposite.
Oh, I see. So it's like creating a map.
Yeah, exactly. A map where words that are similar in meaning, they're clustered close together, and words with different meanings, well, they're further apart.
So happy and joyful would be pretty cozy on this map,
You
right?
know, got it.
Yeah.
And then sad, that would be way over on the other side, showing it means something different. This is how computers start to get synonyms, antonyms, even bigger relationships between ideas.
Wow, okay. Starting to see the light here. And this is all just from those numbers.
It all comes back to the numbers. Think about what this lets us do. Semantic search, grouping similar texts, even personalized recommendations, because we know how things relate.
It's amazing how much is hidden in those numbers. So now, let's talk about OpenAI specifically. How do they create these embeddings?
They use these really sophisticated algorithms, or models as they're called. You give the model text, it gives you back a list of numbers, a vector that represents that text.
So each piece of text gets, like, its own numerical fingerprint.
I like that, yeah. A fingerprint based on its meaning. And here's the key. The distance between these vectors, that's what tells you how related two pieces of text are.
So closer vectors mean, what, the ideas are more similar.
Exactly. Further apart means less related, like cities on a map, right? Closer cities, more connected.
Now that analogy makes sense. So that's how OpenAI can do things like finding related articles or semantic search that goes beyond just matching keywords.
Exactly. It's not just matching words, it's understanding the meaning behind them.
This is fascinating stuff. But I know our listeners are probably thinking, okay, great, but how do I use this in Python? Where do they even begin?
Well, luckily, OpenAI has an API that makes this whole process pretty easy. And they actually include Python code examples in their documentation, which is perfect for someone just starting out.
No slough, straight to the good stuff.
That's right. It's a three-step process, basically. First, you send your text to the API, and you tell it which model you want to use. More on that later.
So we're literally sending like a sentence or a paragraph to OpenAI.
Exactly. Then their model does its thing, crunches the numbers, and generates the embedding vector for that text. And finally, the API sends that vector back to you, ready to use in your Python code.
That sounds surprisingly straightforward. So with just a few lines of code, you can get your first embedding.
You got it. And that vector, that's your key to unlocking all the cool stuff we've been talking about, like semantic search or recommendations.
I'm excited to get to that part. But first, a quick question. I noticed that OpenAI offers different models. So how do we choose which one to use?
That's a good question. In the document you shared, they highlight two main ones, text embedding 3 small and text embedding 3 large. As you might guess, one is smaller and the other is larger, which affects how they perform.
I have a feeling bigger isn't always better here. What's the catch?
You're right. The large model usually does better. It scores a 64.6% on the MTO eval, which is a way to measure how good embeddings are. But the small model is close behind at 62.3%.
So not a huge difference, but I'm guessing there's a cost factor.
Exactly. Think of it like pages per dollar. The small model can handle like 62,500 pages for $1, while the large one is closer to 9,615.
So for $100, you could analyze over 6 million pages with a small model.
That's right, but only about 1 million with the large one. So it's a balancing act, performance versus budget.
Makes sense.
Yeah.
All right, one more term I keep seeing in the docs. Tokenization. What is that, especially for someone new to all this?
Tokenization is how the model breaks down your text into smaller pieces it can work with. like chopping a sentence into words, sometimes even parts of words. OpenAI uses something called Scylla 100K base for this.
So it's not just separating by spaces, there's more to it.
Yeah, the Scylla 100K base encoding is important for estimating costs and avoiding errors in your code.
So another layer of complexity, but important to understand.
Definitely. Okay, so now we know how OpenAI preps the text. Let's talk about what we can do with these embeddings.
Now we're getting to the fun stuff.
Yeah.
We touched on some examples earlier. Search, clustering, recommendations.
Right. So many possibilities. The document talks about question answering, searching text and code, building recommendation systems, even visualizing data.
It sounds like the applications are endless. Remember the document mentioned analyzing Amazon reviews, which feels super relevant these days.
Oh yeah, great example. Imagine you have millions of reviews for a new gadget. Instead of just looking at individual words, we can use embeddings to actually understand what each review is saying. Like, is it positive or negative?
So we can tell if a review is good or bad just based on its embedding vector.
That's the idea. They show how you can combine the short summary and the full review into one embedding so it captures the whole sentiment, positive, negative, or neutral in that one vector.
Wow. Okay, mind blown. So now that you have these sentiment embeddings for each review, what can you actually do with that?
Imagine grouping similar reviews together, seeing trends in what people are saying, or even building a system that recommends products based on reviews that match what you like.
This is incredible. Turning text into meaningful numbers is so powerful.
And we're just scratching the surface. There are even more advanced things you can do, like shrinking those vectors for faster processing or using special databases for storing and searching them.
Sounds like we could do a whole other deep dive just on that.
Absolutely. But for now, I think we've given our listener a really good foundation.
I agree. We went from what is an embedding to actually knowing how to get them using OpenAI's API, choosing the right model, and even understanding that tokenization thing.
All without even looking at the official docs.
Exactly.
Yeah.
But the best part is, now our listener has this mental map, this framework for understanding. So when they do open those docs, it won't be so overwhelming.
That's the goal.
Before we move on, though, I've got one last question. The document mentions that OpenAI's models have a knowledge cutoff date. Is that a big deal for someone just getting started?
It's definitely something to keep in mind. Their newest models, they only know about things up to September 2021. So if you're working with information after that, it might not be the best fit.
So our listeners should think about what kind of information they'll be using and if that cutoff matters for their project.
Exactly. Understanding the limitations is just as important as understanding the capabilities.
Well said. All right, I think it's time to wrap up this part of our deep dive. We covered a lot of ground, but this is just the beginning.
We've built a great foundation, and in the next part, we'll dig into those advanced techniques we mentioned. Stay tuned.
Thanks for joining us, and we'll be back soon for part 2.
Welcome back, everyone. Let's jump right back into our exploration of OpenAI's embeddings. We're going to go a bit deeper this time into some of those more advanced techniques we teased earlier.
I'm ready for it. In the last part, you mentioned something about, like, shrinking those embedding vectors. That piqued my interest.
Yeah, it's a pretty cool concept, and it becomes really important when you're dealing with, bigger chunks of text. Remember those vectors. They can get pretty long, especially with OpenAI's text embedding 3 models. The small model gives you 1,536 dimensions, and the large one, whoa, 3072 dimensions.
3072 dimensions. That's a lot. So reducing the dimensions means making those vectors shorter, right? More manageable. But don't we lose information by doing that?
That's the trade-off, for sure. But the interesting thing is you can often reduce the dimensions a lot without losing too much accuracy. It's finding that sweet spot, optimizing for efficiency without really changing what the embedding represents.
Making those embeddings lean and mean. What are the benefits of doing this, practically speaking?
Well, a few things. First, it makes computations faster, especially when you're working with huge amounts of data. Imagine processing millions of those long vectors. Reducing their size can speed things up big time.
Makes sense. Less data to crunch equals faster processing.
Yeah.
I'm guessing it also affects storage.
Got it. Smaller vectors mean less storage space, which is always good. And don't forget about visualization. Try plotting 3072 dimensions on a graph. It's a nightmare. Reducing those dimensions can make things much easier to actually see and understand.
So it's all about balancing, like capturing enough information, but also making the data practical to work with. Are there, like, specific methods for reducing dimensions?
Oh yeah, tons of techniques, each with its own quirks. PCA, Principal Component Analysis, is one, and TSNE, which stands for T-Distributed Stochastic Neighbor Embedding. These are designed to Basically, squeeze the most important info out of those high-dimensional vectors while minimizing what's lost.
Okay, so dimension reduction is all about efficiency without sacrificing too much accuracy. Now let's switch gears a bit and talk about another thing you brought up earlier. Vector databases. Why do we need those when we already have, regular databases?
Imagine you're building this awesome search engine, right? Powered by OpenAI's embeddings. You've got millions of documents, each with its own vector representing its meaning. Regular databases, they're good for names and addresses and numbers, but they're not made for storing and searching through these crazy high-dimensional vectors.
It's like trying to fit a square peg in a round hole.
Exactly. That's where vector databases shine. They use special algorithms and indexing techniques to make searching through tons of vectors super fast. It's like a library built specifically for finding books based on what they're about, not just their titles or authors. You can do lightning-fast searches based on the meaning captured in those embeddings.
So they're essential for anyone working with embeddings on a larger scale, not just playing around with small data sets.
Absolutely. OpenAI even has resources on GitHub to help you get started with them. If you're serious about embedding, vector databases are the way to go.
Okay, so we've talked about reducing dimensions, vector databases, all this cool stuff. But remember that knowledge cutoff date we talked about before?
Yeah.
Is that a big roadblock for someone who's just starting with embeddings?
It depends, really, on what you're trying to do. You got to think about the kind of information you're working with. If it's stuff that happened after September 2021, like real-time social media trends or recent events, these models might not be the best choice.
So aligning the tool with the task, as always.
Exactly. But for a lot of applications, it might not be a huge deal.
Like I imagine for things like semantic search or clustering documents, it wouldn't matter as much as, say, trying to generate news summaries or something.
Right. It all comes down to knowing your tools and their limitations.
So much to think about. Well, we've covered a lot in this deep dive. We started with the basics of embeddings, explored OpenAI's API, talked about choosing models, and even went into these advanced techniques.
It's been quite a journey. And remember, the whole point of this is to give you the knowledge and confidence to explore the OpenAI documentation on your own.
Now you've got this mental framework. You understand how embeddings work, how to create them, use them, even evaluate them.
So go out there and embed, experiment, explore, and don't be afraid to dive into those official docs.
Great advice. Before we wrap up this part, I have one final question that's been on my mind. We've focused so much on text embeddings, but are there other types of embeddings? Like, could you have embeddings for images or music or even videos?
Whoa, you're thinking outside the box. And you're absolutely right. The same principles can be applied to other types of data. Imagine representing images, sounds, even movies as vectors. But that's a deep dive for another day.
Now I'm really curious. It seems like embeddings have applications far beyond what I initially thought. But for now, we've laid a really solid foundation for understanding and working with OpenAI's text embeddings.
And that's what matters. You're ready to tackle those docs and start building cool stuff with embeddings in your Python projects.
Awesome. Thank you so much for guiding us through all of this. We'll be back soon with the final part of our deep dive to wrap things up. Stay tuned. All right, welcome back for the final part of our deep dive. We've talked about what embeddings are, how to create them, even some advanced techniques, but there's one big piece we haven't really touched on yet.
Yeah, you're right. We focused on the how-to, but how do we know if our embeddings are actually good? How do we measure how well they're working?
That's a crucial point. It's great to have these numerical representations, but we need to make sure they're actually capturing the meaning and relationships we care about.
Exactly. Evaluation is key. It tells us if those embeddings are doing what we expect them to do, if they're right for the job.
So is there like an embedding accuracy score? Some magic number that tells us how good they are?
I wish it were that easy. Unfortunately, there's no single score that captures everything. The metrics we use really depend on what we're using the embeddings for.
Okay, that makes sense. So let's say we're building a semantic search engine. How would we evaluate the embeddings in that case?
For search, we'd probably look at things like precision and recall. Precision tells us how many of the results we get back are actually relevant to what we searched for, and recall measures how many of the truly relevant things we actually find.
So a good semantic search system, powered by embeddings, would have high precision and recall, meaning it finds a lot of the right stuff and doesn't miss too many important things.
Exactly. And there are other metrics for different tasks. Like for clustering, we might use something called silhouette score, which measures how well separated the clusters are, basically how similar things are within a cluster compared to other clusters.
It sounds like there's a whole science behind evaluating embeddings with different tools for different jobs.
It is, and it's always evolving. New metrics and benchmarks are being developed all the time to assess how well embeddings are performing.
So our listeners shouldn't expect a simple answer when it comes to evaluation. It's about understanding the task, choosing the right metrics, and then testing and refining those embeddings based on what you find.
Couldn't have said it better myself. It's an iterative process, always testing, analyzing, improving to make sure our embeddings are doing what they need to do.
Well, this has been quite the deep dive. We started by demystifying what embeddings are, explored how OpenAI creates them, talked about using their API, even delved into advanced techniques and evaluation.
And remember, the goal was to prepare you to explore the official documentation with confidence.
You've now got a solid foundation. You understand the core concepts, how to use them, and even how to assess if they're working well.
So go out there and start embedding, experiment, explore, and don't be afraid to dive into those official documents.
That's what it's all about. Thank you so much for joining us on this deep dive into the world of OpenAI's embeddings. We hope you've enjoyed it, learned a ton, and feel empowered to start using this amazing technology.
Absolutely. And remember, the world of AI and natural language processing is always moving forward. There's always something new to learn and explore.
So stay curious, keep learning, and see what you can create with this incredible technology. Until next time, happy embedding. All right, everyone, get ready.
Yeah.
Because today, we're going deep into the OpenAI documentation.
Woo, exciting.
Yeah. And
Yeah.
specifically,
Yeah.
their moderation API.
Right.
So if you are a Python beginner,
Mhm.
maybe with like 3 months of experience
Yeah.
under your belt,
Yeah.
this deep dive is really for you.
Okay, cool.
We are going to try to build like a mental roadmap for you so
Yeah.
you can navigate this API confidently,
Right.
even if you've like never touched it before. So
Right.
with us today, we have an expert to help us break it all down.
That's right. We'll try to cut through all that jargon
Perfect.
and give you a really clear picture of
Well,
how it all works.
So
Bye.
let's just start with the basics.
Okay.
What is this moderation API?
Okay.
I know it's about like content, but
Mhm.
what's the core idea?
Sure. So think of it like a super smart filter for text and images.
Okay.
Its job is to spot content that could be harmful
Mm-hmm.
so that developers can then take action on it, like filtering it out or maybe intervening with the user,
Gotcha.
just thing like that.
Okay, so it's not just about like blocking bad stuff.
Right.
It's like also about giving developers different options
Exactly.
for how to handle it.
Yeah.
I think one thing that surprised me when I was like prepping for this is that it's free to use,
It is.
which is really cool.
Yeah, it's fantastic for developers who want to build
Right.
safer online spaces and
Victor.
environments. Yeah.
So I noticed in the documentation,
Okay.
they mentioned different models.
Mm-hmm.
Is that like choosing different filters
Yeah.
for different situations?
Yeah, you got it. Exactly.
Right.
So there are two main models.
Okay.
There is Omni Moderation Latest
Okay.
and Text Moderation Latest.
Okay.
And so the Omni model,
Mhm.
that one is kind of like your all-in-one powerhouse.
Okay.
It's newer.
Right.
It handles both text and images.
Cool.
And it has more categories for classifying content.
So if I'm starting like a new project, Omni is probably like the way to go.
I would say absolutely.
All right.
Yeah, TAC Moderation Latest, that's the older model.
Right.
And it's limited to just text
Okay.
with fewer categories.
Gotcha.
It's still useful.
Right.
But yeah, for new projects.
Yeah.
Definitely Omni, I think,
Cool.
is the clear winner.
All right. So enough theory. I'm ready to like see this in action.
Yeah, me too.
You mentioned this is great for
Yeah.
Python beginners.
Sure.
So can you walk us through just like a simple example?
Sure.
Like how would we use this API in our code?
Okay, so let's say you are building a platform
Okay.
where users can upload images.
Okay.
And you want to make sure that no harmful images
Right.
are going to slip through the cracks.
Exactly.
So in your Python script,
Yeah.
you would start by importing the OpenAI library,
Okay.
and then you create what's called a client object
Mm-hmm.
to interact with the API.
Okay.
And then finally, you use what's called the
Yeah.
moderations.create function, and you would specify the Omni Moderation Latest model
Yeah.
and pass in the image that you want to check.
That's it.
Yeah.
That sounds pretty straightforward,
It is pretty straightforward, yeah?
even for me.
Yes.
So what happens like after we run the code?
Okay.
What does the API like actually tell us?
It gives you back what's called a JSON response.
Okay.
That is very readable. It's designed to be human readable,
Mm-hmm.
and it will tell you if the input was flagged.
Okay.
It will break down the different categories of
Hmm.
harmful content that it detected,
Yeah.
and it'll even give you like a score for each category.
So like a score of like how likely it is that the content
So, yeah.
falls into that category.
Yeah, precisely.
Right.
And the Omni model also has a really unique field
Okay.
that's called category applied input types,
Whoa.
which is a mouthful,
Oh, that is a mouthful.
but it basically tells you which input types,
Oh,
like text or image,
yeah.
contributed to a flag. So, for example, if you are analyzing like an image that has text on it,
Right.
it will tell you if it was the image,
Wow.
the text, or both
That's cool.
that triggered that specific category.
It's like the detective explaining their
Yeah.
reasoning, which is really helpful
Exactly.
for developers.
Yeah.
So do you remember that example
Yeah.
with the war movie image?
I do, yeah.
It got flagged for violence.
Yes.
It did. And so the category applied input types would have shown that the violence flag was triggered
Right.
by the image content.
Yes, exactly.
Interesting.
Yeah.
So we've seen violence
Yeah.
like in action.
Yeah.
What other types of harmful content
Sure.
can this API pick up on?
Okay.
Is there like a whole list
Yeah.
of categories?
There is, yeah. It covers a lot of ground.
Okay.
Everything from harassment and hate speech
Mhm.
to self-harm and violence.
Oh,
It can
wow.
even flag things like
Okay.
content that's promoting illegal activities
Right.
or sexual content.
Wow. That's a lot.
Yeah.
Does it get very specific
It,
within those categories?
absolutely.
Yeah.
So, for example, hate speech that is aimed at a protected group
Okay.
that is classified as hate, while the same content that is aimed at a non-protected group
Yeah.
is flagged as harassment.
That's really interesting.
Yeah.
That's like a really nuanced distinction.
It is.
That
Yeah.
makes you realize like how complex
Exactly.
content moderation can be.
Yeah, it's not just black and white.
Right.
There's a lot of gray area.
Exactly.
And you have to think about the context
Yeah.
and the target
Yeah, 'cause
and
it's
all
about
these different factors.
who you were trying to protect
Exactly.
with this moderation.
Uh-huh.
So, and then another layer of complexity, I think,
Uh,
is that this moderation model
yeah,
is constantly being improved,
it is.
which means like any custom policies
Mm-hmm.
that are based on these categories
Mm-hmm.
and scores might need to be adjusted over time,
Right.
which is kind of a bummer,
It
but
makes sense though, right?
it makes sense.
Yeah, because like online trends, they
Yeah.
change so quickly.
Right.
And so the API needs to keep up with that.
Yeah, it's like a moving target.
Moving target, exactly.
Yeah, for sure.
So speaking of which,
Okay.
let's dive into
Let's do it.
these content classifications.
Right? Yeah.
I think there's a lot to uncover there.
Yeah, there is. Okay, so let's unpack some of these content classifications.
Okay.
So we'll start with like harassment,
Okay.
which covers content that expresses, incites, or promotes
Mhm.
harassing language towards any target.
Okay.
It's important to note this category is text only.
Okay, so if someone uploads like a threatening image,
Right.
but there's no text with it,
Mhm.
that wouldn't fall under harassment.
Correct. Yeah, the harassment category
Okay.
really looks at written content specifically.
Gotcha.
However, if that image was accompanied by harassing text, okay,
Then yes, it could still contribute to a flag.
okay, that makes sense.
Yeah.
It seems like the API is like very precise
Mm-hmm.
about what it's analyzing for each category.
Is.
So what about harassment threatening?
Oh, okay.
How's that different?
So harassment threatening takes it a step further.
Okay.
It covers content that includes threats of violence
Right.
or serious harm.
Okay.
So think of it as like escalating from general harassment to a more serious level of threat.
Gotcha.
And like harassment, this one is also text focused.
Okay, so we're like drawing a clear distinction between those two.
Exactly, yeah.
Okay, what about hate content?
Okay.
What does that encompass?
So hate refers to content that expresses insights or promotes hatred based on protected characteristics like
Like-
race, gender, ethnicity, religion, things like that.
Right, like those protected groups we talked about earlier.
Exactly.
So if someone makes like a hateful comment about,
Mm-hmm.
I don't know, a political party, that wouldn't be flagged as hate.
Exactly. That would likely fall under harassment
Okay.
since political affiliation isn't a protected characteristic
Right.
in the same way that
Yeah.
race or religion are.
Gotcha.
So it's really about the target
Oh,
of
yeah.
that hateful content.
These nuances really matter.
They
When you're like building a moderation system,
absolutely.
it's not as simple as just
Yeah.
flagging anything negative.
Yeah, it's much more nuanced than that.
What about hate threatening?
Okay.
Is that similar to harassment threatening?
Yes. So hate threatening combines hateful content
Okay.
with threats of violence, specifically targeting those protected groups.
Gotcha.
And like the other threatening categories, it's also focused on text.
Okay, so we've covered harassment and hate speech.
Mm-hmm.
But like harmful content kind of goes beyond that.
Right.
What about content that's promoting illegal activities? Is
Yeah.
there a category for that?
Yeah, so you're thinking of the illicit category. This one is interesting because it's only available
Oh, okay.
in the Omni model,
Okay.
which kind of highlights its
Yeah.
broader scope.
Right, our all-in-one powerhouse.
Exactly.
So what falls under illicit content?
So illicit content provides instructions or advice
Okay.
on how to engage in illegal activities.
So like shoplifting.
Yes, think of things like shoplifting,
Okay.
drug manufacturing, other criminal acts.
So like a tutorial on how to pickpocket?
Most likely, yeah, that would probably get flagged.
Okay.
And there's also a subcategory
Okay.
called illicit violent,
Okay.
which flags content promoting illegal activities
Okay.
that also involve violence or weapons.
So they're drawing clear distinctions
They are.
between different levels of severity
Yes.
within each category.
Exactly.
What about content related to self-harm?
Okay.
Is that covered?
Yes, so the self-harm category
Yeah.
is dedicated to content that promotes, encourages,
Mm-hmm.
or depicts acts of self-harm, including suicide, cutting, and eating disorders.
Oh.
And this one applies to both text and images.
Okay, that makes sense.
Yeah.
It's not just what people are saying, but
Right.
also like what they're
Yeah.
sharing visually.
Mm-hmm.
Does the API differentiate between someone like
Yeah.
expressing an intent to self-harm
Yes.
versus providing like instructions
Right.
on how to do it?
It does. So self-harm intent
Okay.
flags content where someone expresses that they are currently engaging
Okay.
in self-harm or intend to do so.
Gotcha.
Whereas self-harm instructions focuses on content
Okay.
that provides specific instructions or advice
Gotcha.
on how to carry out those acts.
So like a website providing like dangerous tips
Yes, exactly.
or self-harm would fall under self-harm instructions.
Exactly.
Seems like those subcategories
Yeah.
allow for more like targeted interventions.
Could do, yeah.
What about sexual content?
Okay.
Does the API handle that?
So the sexual category encompasses anything intended to arouse sexual excitement,
Go ahead.
such as descriptions of sexual activity or content
Mhm.
promoting sexual services. But it's important to note
Yeah.
that it excludes sex education and wellness materials.
Okay, good.
So we don't want to be
Yeah, we don't want to flag.
flagging educational resources
Right, exactly.
as being harmful.
I'm assuming there's a subcategory
Yes,
for content involving minors.
you're right. So sexual minors is specifically for sexual content that includes an individual under
Right.
18 years old.
Right.
And given the sensitive and illegal nature of this category,
Yeah.
it's really crucial that the API is able to
Right.
accurately identify this type of content.
Absolutely. Okay. So we're down to our final two categories.
Okay, let's do it.
Violence and violence graphic.
All right.
How are these different?
So violence covers any content that depicts death,
Mm-hmm.
violence, or physical injury.
Okay.
This could range from like a news report
Right.
about a violent crime to a scene from a violent movie,
Gotcha.
whereas violence graphic is more specific,
Okay.
targeting content that depicts violence
Okay.
in a particularly graphic or disturbing way.
So like a war documentary
Yeah.
might be flagged for violence, but a slasher film would probably fall under violence
Yeah,
graphic.
you got it.
It's about like the level of detail
Yeah,
and potential for harm.
exactly. Yeah, it's
Yeah.
all about context
That's
and the
all.
level of intensity.
And like many of the categories we've discussed,
Mm-hmm.
both violence and violence graphic can be flagged
Yeah.
in both text and images.
Right.
So the API is analyzing both the words and the visuals
It is.
to determine like the appropriate category.
Exactly.
This is a lot to take in,
It is.
but it's really fascinating to see
yeah.
how the API breaks down these
Mhm.
complex categories and analyzes content so thoroughly.
It does a really good job.
Now that we've gone through the content categories,
Uh,
I'd love to circle back
Yeah.
to the Python code example
Yeah.
we talked about earlier.
Let's do it.
Can we actually see what that code looks like
Yeah,
and how it works?
absolutely. Let's
Okay.
take a look. Okay, so here's that simple Python code snippet
Okay.
for using the OpenAI moderation API.
Awesome.
So we start by importing the OpenAI library,
Okay.
which gives us all the tools we need to
Hmm.
work with the API.
Okay, cool.
Then you need to set your API key.
All right.
You can find this on the OpenAI website.
Right.
And this key authenticates your request to the API.
So it's like your unique ID
Exactly.
that lets OpenAI know
Mhm.
it's you making the request.
Yeah.
Got it.
Perfect.
And then we define the path to our image.
Yes.
I see you've put path to your image.jpg.
Right.
Do I actually type that in?
No, that's just a placeholder.
Okay.
You would replace that with the actual path
Right.
to your image file on your computer.
Gotcha. Okay. That makes sense.
Perfect.
What's happening with that with OpenBlock?
So this is a really neat way to handle files in Python.
Okay.
It opens the image file,
Yeah.
reads the data,
Mm-hmm.
and then automatically closes it for us,
Okay.
even if there's an error.
Oh, cool.
So this ensures that we are not
Ugh.
leaving any files open unnecessarily.
So it's like opening a door,
No.
doing what you need to do,
Right.
and then making sure to close it behind you.
Exactly. Yeah. Good practice.
Good practice. Okay.
And then we call the OpenAI.moderations.create function.
Okay.
And this is where we actually send our request to the API.
Okay.
We tell it which model to use,
Yeah.
in this case, Omni Moderation Latest,
Right.
and provide the image data as input.
And finally, we print the response.
Yes,
This is where we get to see the
Yeah.
results of the analysis.
exactly. So the response will be a JSON object
Okay.
containing all that information we talked about earlier,
Yeah.
whether the image was flagged, the
Yeah.
categories,
Yeah.
the scores, and so on.
This code snippet is super helpful.
Good.
It really makes the API feel
Awesome.
way more accessible.
Yeah.
I can imagine like a Python beginner
Yeah.
looking at this and thinking, okay, I can actually do this.
I hope so.
You know?
That's what we are aiming for.
Yeah.
The goal is to demystify
Right.
that OpenAI documentation
Yeah.
and empower developers
Totally.
using this really powerful tool.
Well, mission accomplished. I
Nice.
think we have covered a lot of ground today.
We have.
From the basics of the moderation API
Yeah.
to understanding like the different content categories and even diving into like a real code example.
Yeah. It's been a really thorough deep dive.
It has.
Yeah.
And I think our listeners are now well equipped
I think so.
to explore the documentation on their own
Yeah.
and start experimenting with the moderation API.
I agree.
All right, deep divers, that wraps up our exploration
Yeah.
of the OpenAI moderation API.
It does.
We hope you enjoyed this journey and feel empowered to unlock the world of content moderation.
Until next time.
Keep diving deep. Hey everyone, welcome back. Today we're doing a deep dive into OpenAI's documentation.
Ooh, exciting.
Yeah, and we're going to be focusing on reasoning models today.
Okay, cool.
And basically, think of this deep dive as like a pre-flight checklist,
Okay.
like before you jump into that cockpit.
Makes sense.
So we're going to be looking specifically at, we know you're a Python beginner. We're assuming you have about 3 months of experience under your belt.
Right.
We're going to be making sure everything is super clear for you, so there's no jargon, no confusion.
Gotcha.
We want this to be a smooth, easy to understand journey through these docs.
Yeah, absolutely.
We're going to be using the 13 reasoning models, OpenAI API.pdf
Perfect.
as our guide. And by the end of this, you'll be navigating it like a pro.
Yeah, we want you to feel empowered to use these tools and not intimidated by them at all.
Exactly. So let's jump right in. The document starts off by talking about these advanced reasoning models, O1 and O3 mini, and they're trained with something called reinforcement learning,
All right.
which helps them tackle complex problems in ways that, regular coding just sometimes can't.
Right.
So think problem solving, coding challenges, scientific reasoning, even planning out multiple steps.
Yeah, absolutely. And what's really cool is that these models, they kind of actually think things through before giving an answer.
Wow.
It's not just a quick lookup. They're actually generating a whole chain of thought internally.
That's pretty neat.
Almost like a human working through a problem step by step.
So it's not just spitting out an answer.
Exactly.
It's actually reasoning its way to a solution.
Yeah.
That's cool. That's really cool.
Yeah.
So how are these reasoning models different from those GPT models that everyone's been buzzing about?
Yeah.
I've played around with those a bit, and they seem pretty smart too.
GPT models are definitely impressive, especially for generating text and code.
Right?
But these reasoning models, they're built for a whole different level of complexity. So imagine, GPT models are like your helpful junior programmers.
Okay.
They're great for specific instructions.
Right, right.
Reasoning models, on the other hand, they're like your senior developers.
Ooh.
They can tackle those complex tasks, but you just kind of give them like high-level guidance.
Got it. So they can kind of figure it out on their own.
Exactly.
That's interesting.
And they even come in like 2 flavors.
Okay.
O3 Mini. You can think of it as like a nimble sports car. It's perfect for quick tasks. And then O1 is like your powerful truck
Gotcha.
when you need that extra horsepower for those really heavy-duty projects.
Okay, so depending on the project,
Yes.
I would choose which model fits the scale, like
Yeah.
what I'm trying to do.
Exactly.
Okay, I got it.
Yeah.
Now, the document mentions something called the reasoning effort parameter,
Okay.
and they actually have a fun little nickname for it.
Oh, yeah.
They call it juice.
Juice. Okay.
What exactly is this juice and how does it work?
So think of reasoning effort, like a dial that you control.
Okay.
And you're basically telling the model like how much brain power to use.
Right.
So it determines how many reasoning tokens the model generates before giving you an answer.
Interesting.
And you have 3 settings: low, medium, which is your default setting,
Okay.
and high.
So it's like setting the difficulty level on a video game.
Ooh, that's a great analogy.
Low for a quick casual run, high for a hardcore challenge.
Yeah.
Or you need every bit of that processing power.
Yeah, absolutely.
I like that.
Of course, there is a trade-off.
Okay.
The higher the reasoning effort, the more it might cost, and the longer it might take to get a response.
Okay, that makes sense.
But for those really tough problems, that extra juice can make all the difference.
Yeah, I can see that.
Yeah.
So now I'm curious, what exactly are these reasoning tokens?
Uh,
Am I picturing it right? Like little pieces of information the model uses to think?
yeah, you got it. So these reasoning tokens, they basically represent the behind-the-scenes work
Okay.
the model's doing before giving you that final answer.
Yeah.
And it's all happening internally, so you don't actually see these.
Okay.
They're like the model's thought process,
Like,
working
right.
through the different steps and possibilities.
Okay.
But then it just shows you, the final solution.
So it's like the model's doing all the calculations on a whiteboard
Exactly.
and then just shows me the final result.
Yes, perfect analogy.
Okay, that makes sense. But if they're hidden, why should I even care about them?
That's a great question. So even though you don't see them,
Okay.
reasoning tokens, they still impact the model's context window.
Okay.
Think of the context window like the model's short-term memory.
All right.
It can only hold so much information at once.
Okay.
And the more reasoning tokens the model uses, the more of that short-term memory gets used up.
Interesting. So if the model uses too many reasoning tokens,
Yeah.
it's like its short-term memory gets full and it might not be able to remember everything
Exactly.
needed to solve the problem.
Yeah, exactly. And that can be a problem, especially because even though you don't see them,
Right.
those reasoning tokens still contribute to the overall cost.
So it's like I'm paying for all the ingredients in a recipe,
Yes,
even the ones that get thrown away
exactly.
after cooking.
You got it.
Okay.
Yeah.
That makes sense. Yeah. So it's not just about the, the visible output, but also about the invisible thinking process
Exactly.
that goes on behind the scenes. It's like we're paying for the model to think, even if we don't see all the steps it takes.
Right.
But how do we make sure that we're not overspending on these invisible reasoning tokens?
That's a good point. And the documentation actually gives us a really handy tool to manage this. It's called the max completion tokens parameter. And this lets you set a limit on the total number of tokens used, so both the visible ones that are in your answer,
Right.
and those hidden reasoning tokens.
So it's like setting a budget for the model's thinking process.
Exactly.
We're saying, hey, you can use this many tokens to figure things out, but no more.
Exactly. And here's why that's so important. If the model hits that limit before it's actually finished its thought process, you'll see something called a finish reason that's set to length.
Okay.
And that's basically the model saying, hey, I ran out of thinking space.
Oh.
And the tricky part is you might still get charged for those tokens even if you didn't get a complete answer.
So it's like paying for a taxi ride that only takes you halfway to your destination.
Exactly.
Not ideal. Not ideal.
Not ideal. So the document recommends, starting with a buffer of at least 25,000 tokens for reasoning and your final answer.
Okay.
And as you get a feel for how much, your typical prompts use, you can adjust this up or down, but it's good to start with that buffer.
Okay, that's helpful. That's helpful.
Yeah.
So now I'm kind of curious about how we actually use these reasoning models.
Yes.
Is it different from using those GPT models that I've played around with?
That is a great question. So remember how we talked about reasoning models being like your senior developers?
Yeah.
Well, just like you wouldn't like micromanage a senior developer. You don't want to like over-instruct a reasoning model.
Right.
You just kind of give it that high-level goal, like the what, and let it figure out the how.
Okay, so if I wanted to like refactor some code, I
Yep.
wouldn't need to spell out every single step.
Exactly. You could just give the model the code and be like, hey, make this more efficient or improve the readability. It's like giving your senior developer a challenge and trusting them to find the best solution.
That's pretty powerful. I like that.
Yeah.
And speaking of examples, the document actually has one that shows how to use the O3 mini model to refactor a React component.
Yes.
And I'd love to unpack that, especially since our listener, is on their Python journey.
Absolutely.
Could we walk through that example together?
Let's do it. So the example starts with like a very simple React component.
Okay.
Like imagine just a basic list of books, each with a title and then a category,
Okay.
like fiction or nonfiction.
Simple enough. I think even with my 3 months of Python experience, I could handle that.
Exactly. And so the prompt that we give the model is actually pretty straightforward. We basically just say, hey, I need you to change the component so that all the nonfiction books have red text.
Okay.
Just give me back the code, no need for fancy explanations, and, keep the lines under 80 characters.
So we're setting the goal, red text, for nonfiction books.
Yes.
But we're not micromanaging the process.
Exactly.
We're letting the model figure out the best way to make that happen.
Precisely. And that's like the beauty of these reasoning models is they can take that high-level instruction and just translate it into, the necessary code changes.
Right.
It's like saying to your senior developer, make this text red, and they know exactly which lines to tweak.
Yeah. I can see how much time and effort that would save me.
Yeah, absolutely.
That's awesome.
It's like delegating those detail-oriented tasks to a super efficient AI assistant.
Exactly.
Right.
Okay, so the document even shows what the output should look like. It's like the updated React component with all the changes
Yes.
that make the nonfiction book titles red. So it's like the model handing in a perfectly formatted report ready to be implemented.
Exactly.
That's so cool. And I imagine this kind of approach can be used for all sorts of coding challenges.
Oh, absolutely.
But what about those other use cases that the document mentioned, like data validation and routine generation?
Yes.
Those sounded really interesting.
Absolutely. So let's imagine you're working with like a large data set.
Okay.
Maybe it's customer information or sales figures.
Okay.
Instead of like manually checking for errors, you could use a reasoning model to automatically validate that data
Wow.
and flag any inconsistencies or missing values. It's like having an AI auditor.
That would be so helpful, especially when you're dealing with massive amounts of data.
Exactly. And then for routine generation, think about tasks that follow a very specific set of steps,
Okay.
like troubleshooting a technical issue or onboarding a new employee or even just making a cup of coffee.
All right.
You can feed a reasoning model information like help center articles or training manuals.
Okay.
And it can generate step-by-step instructions or even code to automate those routines.
Wow, that's like having an AI that can learn from existing knowledge and create customized workflows.
Exactly.
It's almost like having a personal assistant who can take care of those repetitive tasks and then free up our time for, more creative and strategic work.
Exactly. And these are just a couple of examples. The real magic happens when you start thinking about how these reasoning models can be applied to your specific needs and challenges.
Right.
It's like having this powerful new tool in your coding toolkit just waiting to be explored and utilized.
Yeah, this is truly mind-blowing. I feel like we've only just scratched the surface of what's possible with these models. It's so exciting to think about all the ways we could leverage this technology to solve problems, automate tasks, and create innovative solutions.
Absolutely.
But before we get too carried away, I'm curious about one practical aspect, cost.
Yeah.
We've talked about, these reasoning tokens and how they impact the model's thinking process.
Right.
But how do we make sure that we're not breaking the bank while using these powerful tools?
Yeah, that's a great question and a very important one. So let's dive into some cost-saving strategies in our next segment.
Okay.
We'll explore how to be smart about using those reasoning tokens, how to manage that context window effectively,
Right.
and ultimately how to maximize performance without overspending.
Okay, so we've really explored the power of these OpenAI's reasoning models.
Yeah.
And we've seen how they can really tackle these complex tasks like a pro.
Yeah.
But now let's get down to the practicalities.
Right.
How do we use this power responsibly?
Yeah.
Without blowing our budget
Yeah, that's a good point.
on all those reasoning tokens.
So it's kind of like having a powerful sports car.
Okay.
You don't always need to redline the engine to get to where you need to go.
Right.
Similarly, with these models, we can be really smart about how much reasoning effort we use for different tasks.
So when do we need to like crank up that juice?
Yeah.
And when can we kind of take it easy?
So imagine you're building like a simple calculator app,
Okay.
adding, subtracting, basic stuff.
Right.
You wouldn't need the model to go into like deep thought mode for that.
Right.
Setting the reasoning effort to low or medium would be perfect.
Okay.
Quick, efficient, and cost effective.
That's right.
But let's say you're building a program to analyze like complex scientific data
Okay.
or generate, really creative storylines.
Okay.
That's when you might need to turn up that reasoning effort to high to get those nuanced and intricate results.
So it's all about matching the reasoning effort
Yes.
to the complexity of the task.
Big-
Don't use a sledgehammer when a regular hammer will do.
Right.
But what about that context window we talked about? How do we manage that?
Yeah.
So we're not wasting tokens
Yeah.
and, potentially getting cut off mid-thought.
It's kind of like packing for a trip.
Right.
If you try to cram everything into one giant suitcase,
Yeah.
you might end up with a broken zipper and things spilling out everywhere.
I've been there.
Right. Similarly, if we overload the model's context window with too much information,
Okay.
we risk hitting those limits and then not getting a complete answer,
Yeah.
even after paying for all those tokens.
Right. So how do we pack smartly
Yeah.
for these AI trips?
So one approach is to break down those big, complex tasks
Right.
into smaller, more manageable chunks.
Okay.
So instead of giving the model like a massive code base to refactor all at once,
Okay.
maybe focus on one function or component at a time.
Right. Break it down.
It's like organizing your belongings into smaller bags
All right.
within your suitcase.
Gotcha. So everything has its place.
Exactly. And nothing gets lost or crushed.
I like it. And I imagine we can also keep an eye on the token usage as we go.
Yes.
Make sure we're not overspending.
Yeah.
It's like checking the weight of your suitcase as you pack
Exactly.
to avoid those pesky airline fees.
The response object from the API actually tells you exactly how many tokens were used.
Oh, okay.
So you get a clear picture of your budget.
So it's like having a built-in scale
Yeah.
for my AI projects.
Exactly. And as you gain experience, you'll kind of develop a feel for how to optimize your prompts and your tasks
Yeah.
to strike that perfect balance between performance and cost effectiveness.
This has been incredibly insightful, I feel like. I've gone from being intimidated by these reasoning models to being excited to actually use them.
That's great. Yeah.
We've learned how to pick the right model for the job, how to control their thinking process,
Yeah.
and even how to manage those costs.
Yeah, absolutely.
It's great. And remember, this is just the beginning.
Yeah, for sure.
The OpenAI documentation is your playground.
Yeah.
Explore, experiment, and don't be afraid to try new things.
Have fun with it.
I used to look at those docs and feel overwhelmed,
Yeah.
but now I see it as like a treasure map, leading to all sorts of amazing possibilities.
Exactly.
Who knows? Maybe one day you'll be the one writing the documentation,
That's right.
guiding others on their AI adventures.
I like it.
Well, folks, there you have it.
Yeah.
Our deep dive into OpenAI's reasoning models.
It's been fun.
We've gone from the basics to practical strategies, for using these powerful tools effectively and responsibly.
Yeah, absolutely.
I hope you feel empowered to really unlock that incredible potential of AI and build amazing things. Until next time, happy coding. All right, get ready, because today we're going deep into OpenAI documentation. It can be a little intimidating, we know, but we're here to help.
Yeah, no worries.
We'll make it as painless as possible. You can think of this deep dive as like your personalized guide, especially if you're a Python beginner. Like what, around 3 months of experience?
Yeah.
Something like that?
Right.
Okay, cool. So we're going to break down all those tricky concepts and technical terms that you see in there.
For sure.
They're going to give you a clear roadmap before you even open the official docs.
It's like we're building that mental scaffolding so you can go through the documentation with confidence.
Exactly. And one of the most powerful tools that we're going to look at today is structured outputs.
Yeah.
This feature is a game changer when it comes to working with those OpenAI models.
It's huge. Yeah.
But I have to admit, when I first saw JSON schema in the documentation, I almost ran for the hills. I don't know about you.
I totally get that. Jargon can be super intimidating.
Yeah.
But the cool thing about structured outputs is that it actually simplifies things. Imagine you're coding away and you're asking, OpenAI's model all these questions.
Right.
But the answers you're getting back, They just come back in this messy, unpredictable jumble. It's like trying to bake a cake, but your ingredients are scattered all over the kitchen.
Oh, it's chaos. It's total chaos.
So structured outputs brings order to that chaos.
Exactly. Think of it like ordering a pizza.
Okay.
You wouldn't just say pizza and just hope for the best.
No.
Right. You
Yeah.
want to specify the crust, the size, the toppings. You want that order structured in a way that guarantees you get what you expect. And structured outputs does the same thing with these OpenAI models.
So I'm picturing like a neatly organized pizza arriving at my door, but instead of pepperoni and mushrooms, it's, data, but it's formatted exactly the way my Python code needs it. That's so much better than just this jumbled mess of information. Exactly. And that structured data saves you so much time and effort. You don't have to clean it up or try to figure out what's what. You can just plug it right into your code and go.
That's amazing. So the documentation mentions two ways to use this structured outputs thing.
Yeah.
Function calling and something called response_format. And to be honest, that's where I start getting a little confused. What's the difference between those two?
It's a subtle difference, but it is important.
Okay.
Think of function calling as like giving the model tools to interact with your application directly. Imagine you're building a chatbot, right? And you want the model to pull information from a database based on what the user's asking. Function calling lets the model do that behind the scenes.
Oh, wow. So it's not just giving me an answer. It's actually performing actions based on my instructions, almost like it's becoming part of my code, which is pretty powerful.
It is, but for someone starting out with OpenAI and Python, response_format is going to be your best friend. It focuses on structuring the model's direct response to you, so it makes sure that information comes back in a neat, predictable format.
Right. So for our listener who's mainly focused on getting like clean, usable data back from the model, response_format is the way to go.
Absolutely. It's the most straightforward way to start reaping the benefits of structured outputs right away. Now, to really understand how this works, we need to unpack this thing called JSON schema.
Okay. Deep breath.
I know it sounds scary, but I promise it's not as complex as it seems.
Yeah. Whenever I see like schema, my
Okay.
brain kind of shuts down.
Yeah.
But I'm ready to tackle it. What exactly is a JSON schema in this context?
At its core, it's just a way to define the structure of your data using JSON, which, as a Python user, you're probably already pretty familiar with. Think of it like a blueprint that tells the model exactly how you want the information organized.
Okay, so instead of getting back just a random blob of text, I can say, like, hey, I want the answer to have these specific pieces of information, and I want them arranged in this specific order, kind of like a Mad Libs for data.
I love that analogy.
Yeah.
You're giving the model a template, and it fills in the blanks with the information you requested. And the best part is, OpenAI gives you all these Python code snippets
Oh, nice.
that show you exactly how to create these schemas using a library called Pydantic.
Hold on, Pydantic. Is that going to require, like, a computer science degree to understand?
Don't worry, Pydantic is surprisingly user-friendly.
Okay, good.
It actually makes creating and using these schemas so much easier, even for someone who's still relatively new to Python.
Okay, that's reassuring. Now, the documentation mentioned something about the first request,
Sure.
with a new schema being a bit slower.
Yeah,
What's that about? Why is that?
that's a great question. The first time you use a new schema, the API has to process and understand it, kind of like the model is learning the structure you want. But once it's done that, all subsequent requests using that same schema are lightning fast.
So it's like the first time you bake a cake, it takes a while to gather the ingredients, figure out the recipe, but the next time you already know what to do, and it's much quicker.
Perfect analogy.
Yeah.
So we've got the basic idea of schemas and response_format down, but I think seeing a real-world example would really bring this home. And luckily, the OpenAI documentation has this fantastic one using what's called a chain of thought math tutor.
Okay, that sounds intriguing. I think we need to dive into that in our next segment. Let's break down that code and see how it all comes together to create this math tutor.
Yeah, let's do it. So this math tutor example, it really shows how structured outputs can be used to get more than just a simple answer from the model.
Okay, I'm intrigued. How does this chain of thought concept come into play? It sounds like we're getting into the model's head a bit.
Exactly. It's like, imagine you want the model to not just solve the math problem, but actually explain its reasoning step by step, like a human tutor would.
Right. That's where chain of thought comes in, and we can use structured outputs to make those steps really clear and organized.
So instead of just seeing, 2 + 2 = 4, we'd get a breakdown of how the model actually got to that answer. I can see how that would be incredibly useful for learning.
Right, exactly. So let's look at the code. First, it defines a schema using Pydantic for each step in the reasoning process.
Okay.
It's basically saying, hey, each step needs to have an explanation and an output.
So it's like setting up the structure for each, I don't know, each thought bubble the model has on its way to solving the problem.
Yeah, I like that.
Yeah.
And then there's an overall schema for the entire response, which includes, a list of those steps and a final answer, all neatly packaged.
Okay, I'm seeing that in the code snippet now. It's almost like those Russian nesting dolls with one structure tucked inside another. Exactly, you got it. And then this beautifully nested schema is what's used in the API call. You're essentially saying to the model, all right, when you solve this math problem, I want you to present your answer using this specific structure. No more messy jumbles allowed.
And the model actually does it.
Yeah.
It follows that schema and lays out each step with an explanation.
It's pretty remarkable.
Wow.
You get this structured breakdown of the model's reasoning, not just a final answer. It's like having the model show its work, which is a game changer for understanding its process.
Yeah, that's way more insightful than just getting a bare bones answer. I'm starting to see how powerful this could be for all sorts of applications, not just math tutoring.
Absolutely. Anytime you need reliable, predictable data from the model, structured outputs is your go-to.
Right.
Think about extracting information from articles or, generating code in a very specific format or even creating data for, a chatbot to use. The possibilities are pretty much endless.
Okay, my mind is racing with ideas now.
Yeah.
But let's get back to reality for a second. What happens when the model just can't answer?
Yeah.
Maybe the question is too vague or it hits some kind of safety limit. Does structured outputs just break down?
That's a great question, and it brings up a really important concept, refusals.
Okay.
So the API is smart, right? It's designed to recognize when it can't provide a structured answer based on the schema you gave it.
Right.
In those cases, the API response will actually include a refusal property.
So instead of my code crashing or getting weird data back, it can actually recognize that the model refused to answer and handle it gracefully.
Exactly. It's like having a built-in safety net.
That's really nice.
It's always a good practice to include error handling in your code to deal with those refusals, especially if you're working with, user-generated input, which can be unpredictable.
Right. You never know what kind of crazy questions people might come up with.
Yeah.
Speaking of user input, the documentation really emphasizes being super clear in your prompts when using structured outputs. Why is that so important?
It all comes down to setting the model up for success.
Okay.
If your instructions are kind of vague, the model might try to force its output into the schema, even if it doesn't really get what you're asking. And that could lead to inaccuracies or what we call hallucinations, where the model's just making things up.
So clear communication is key. Even with all these fancy tools, it's like garbage in, garbage out, right?
Exactly.
Okay. Now, there's another feature mentioned in the documentation that I'm curious about. It's called streaming. What's that all about? It sounds like something out of Netflix.
Well, in a way it is. Streaming is all about getting real-time results from the API.
Okay.
So instead of waiting for the entire response to come back, you can actually process it piece by piece as it's being generated. It's really useful for interactive applications where you need that immediate feedback.
Okay. I think I'm getting it. But wouldn't you want the complete answer anyway? Why break it up into chunks?
It depends on what you're building.
Okay.
Imagine you're creating a chatbot, right? With streaming, you can display the model's responses as they're being generated, so it makes the conversation feel much more natural and dynamic. Or if you're dealing with a huge amount of data, streaming lets you start processing it immediately rather than waiting for the entire thing to download.
So for things that need to feel really responsive and handle lots of information, streaming can be a real lifesaver.
Totally.
And the documentation provides code snippets for streaming using a stream helper in Python.
Exactly. It's all there for you. So far, structured outputs seems like, a dream come true.
Yeah.
But are there any limitations we should be aware of? I mean, every tool has its quirks, right?
That's a great question. It does seem almost too good to be true. What are the catches?
Well, like any tool, structured outputs has its boundaries. For one thing, there are limitations on the types of data you can use in your schemas and how complex those schemas can get.
Right.
You can't just throw anything in there.
So I can't build a schema to represent the entire Library of Congress, for example.
Probably not the best use case. You're mostly limited to those standard JSON data types, so strings, numbers, booleans, objects, arrays. There are some more advanced data structures that you can't use, and there are limits on nesting, and the overall size of your schema.
Okay, so it's powerful, but it's not limitless. That makes sense. What about those situations where structured outputs just isn't an option? Is there any other way to make sure the model gives me valid JSON output?
There is. The OpenAI documentation mentions something called JSON mode, which acts as a fallback when you can't use a full schema.
Gotcha.
It's less about controlling the exact structure and more about ensuring that you get back valid JSON data that you can actually work with.
So it's like a good backup plan when you just need that extra assurance. But even in JSON mode, it's still crucial to explicitly tell the model to produce JSON in your prompt, right?
Absolutely. Clear communication is key, remember.
Yes.
Now, before we wrap up, there's one important detail about structured outputs that often trips up beginners.
Okay.
It's something you'll want to keep in mind when you're designing your schemas.
Oh, a cliffhanger. I think we need to save that for our final part. Don't go anywhere. We'll be right back to reveal this crucial detail. Okay, we're back, and I'm, like, dying to know this crucial detail about structured outputs that you mentioned. What is it that trips up beginners?
It's this. With structured outputs, every single field in your schema has to be marked as required.
Wait, really? So even if I think a piece of information might not always be there, like, I don't know, an optional email address,
Yeah.
I can't make it optional in the schema.
Yeah, that's the catch. It might seem a little counterintuitive at first, but there's a clever workaround.
Okay, I'm all ears.
You can use what's called a union type that includes null. So for your email example, you could define the field as a union of string and null.
So the model will always try to fill that field, but it might fill it with a null value if it can't actually find an email address.
Right.
That's a pretty neat trick.
Exactly. It's a way to kind of emulate optional fields within the constraints of structured outputs. Now, the documentation also mentions some limits on nesting and the overall size of your schemas.
Right, I remember seeing that. It's all about keeping things manageable, right?
Precisely. You can't have like infinitely nested objects or super long lists of values. There are specific limits outlined in the documentation, things like a maximum of 100 object properties and 5 levels of nesting.
So no building a schema to represent the entire Library of Congress, I guess.
Probably not a good idea, but honestly, for most real-world scenarios, you're going to be well within those limits. Now, there's one other phrase in the documentation that often causes confusion. Additional properties. False.
Yeah, that one sounds pretty technical. What does that mean in plain English?
It's a simple but important rule. It basically means your JSON object can only contain the fields you've defined in the schema. Nothing else, no extras allowed.
Okay. Why is that rule so important? It seems a bit strict.
It all comes back to that idea of predictability and consistency, which is the whole point of structured outputs.
Right.
If the model could just throw in random extra fields whenever it felt like it, you'd be back to square one with messy, unpredictable data.
So additional properties, false, is like putting up those guardrails to make sure the model stays within the boundaries we defined. Got it.
Exactly. Now, even with all these amazing features, we have to remember that structured outputs is still relatively new. There might be times when it's not the perfect tool for the job.
Right, like if you need a super complex schema that pushes those limits we talked about, or maybe if you're using an older OpenAI model that doesn't fully support it.
Exactly. But even in those cases, you've got JSON mode as a solid backup option.
Right. Okay, so to wrap things up, what are the key takeaways for our listener who's ready to, tackle the OpenAI documentation and start building amazing things?
First, structured outputs is your new best friend. It's going to save you tons of time and headaches by making sure that the data you get back is ready to use in your Python code.
Perfect.
Second, don't let JSON schema intimidate you. It's all about creating those blueprints for your data, and Pydantic makes it surprisingly easy.
And
Third, keep those key details in mind. Every field is required, there are limits on nesting and size, and you need to set additional properties to false.
And finally,
If all else fails, JSON mode is there to save the day.
I feel like we've given our listener a solid foundation to dive into the OpenAI documentation with confidence and excitement,
Yeah.
not confusion and fear.
Yeah.
Any final words of wisdom before we sign off?
Just this. Think about how structured outputs can not only organize the model's output, but potentially even improve the model's reasoning. By encouraging it to think step by step and provide information in this very specific structure, you might actually be helping it generate better, more logical responses.
That's a fascinating thought. It's like we're training the model to think more clearly just by using this tool.
Exactly. It's a really powerful concept, and I'm excited to see how developers will continue to innovate with it.
And on that note, we'll leave you to explore the world of OpenAI. with your newfound confidence.
Have fun out there.
Thanks for joining us on this deep dive, and until next time, happy coding. All right, let's dive into OpenAI documentation and how to really make it work for you, especially if you're starting out with Python, let's say, about 3 months of coding experience under your belt.
Okay, yeah.
I totally get it. Diving into any new documentation can feel a bit like walking into a giant library with no map.
Right.
But that's exactly what we're here to do, provide you with that map to the OpenAI docs.
Yes.
Break down all the jargon, show you what's actually important, and by the end, hopefully, you'll be feeling a lot more confident about using those docs.
That's a great way to put it. The OpenAI team has packed those docs with so much useful information and examples.
Absolutely.
It's really just about knowing where to look and how to use it for what you're trying to do.
Exactly. So I actually came across this feature called predicted outputs while I was browsing around. Have you used this in your own work at all?
Oh yeah, definitely. Predicted outputs is a huge help, especially when you're working with large amounts of text or code and you're only changing small parts. It's kind of like, imagine you're working on a Python project and need to change a long function.
Okay.
Instead of having the model regenerate the whole thing, you can use predicted outputs. So
Yeah.
you give it that original function as a prediction.
Right.
Then it focuses on generating just the changed parts.
So it's like saying, hey, here's the blueprint. Just focus on these specific areas that need updating.
Exactly. It really optimizes your workflow and makes the most of the API, especially for someone starting with Python and maybe not comfortable with big chunks of code yet.
Totally. Okay, so let's say I'm using predicted outputs. How do I know which parts of my prediction it's actually using and which parts it's ignoring?
Right. So when you get the response back from the API, it actually tells you about the accepted prediction tokens and the rejected prediction tokens.
Okay.
Tokens are like the individual units of text that the model uses, kind of like the building blocks.
So accepted prediction tokens are the parts it used directly,
Right.
and the rejected ones are the parts it decided to, toss out.
Yeah, exactly. It's like getting a peek behind the curtain to see how the model is making decisions.
I like that. Transparency is super helpful when you're still learning. But I have to ask, what about those rejected tokens? Are we still getting charged for those even though they weren't used?
That's a really good question, and it's important to think about when it comes to cost. Unfortunately, even rejected tokens count toward your total token usage.
Okay, that makes sense. So it's a bit of a balancing act. We want to use predicted outputs efficiently, but also be mindful of those rejected tokens.
Absolutely, yeah. It's like optimizing your code, right? You want it to run fast, but you also have to think about how much memory it uses.
Exactly. So
Yeah.
finding that sweet spot and knowing when to use it is key.
Yeah, and as you get more experience with the API and Python, you'll get a better feel for that.
Cool. I'm starting to see how helpful this could be for my own projects. Now, the documentation also mentions something about combining predicted outputs with streaming for even faster responses.
Right.
What's that all about?
So imagine you're running a long Python script and you're waiting for the output all at once. It can take a while, right?
Oh, yeah.
Streaming lets you get the response in chunks, so you don't have to wait for the whole thing to finish.
It's like streaming a video online instead of downloading the whole file first.
Exactly.
Yeah.
For someone new to Python, it can make it feel a lot more interactive.
Right.
You can see things happening line by line, and it can even help you understand how the model's working and catch problems earlier.
I like that much better than feeling like you're throwing code into a black box and hoping for the best.
Yeah, exactly.
So we've talked about providing the prediction at the beginning of the output. What if I want to change things that are scattered throughout the text or code? Can predicted outputs handle that?
That's where it gets really interesting. You don't have to put all the predicted text at the beginning. It can
Okay.
be anywhere in the response, and you still get those benefits.
Really?
Yeah.
Anywhere? That's amazing.
Yeah. The documentation is a cool example with a Ono server. The predicted text is at the beginning and the end, with the new stuff in the middle.
It's like giving it bookends, and it fills in the missing pages.
Yeah.
But how do we know it's actually using those scattered predictions correctly?
You can look at the accepted prediction tokens again. In that Ono server example, you'll see that it did use them.
Okay, that's making a lot more sense now. But I'm guessing there are some limitations to predicted outputs.
You're right. There are a few things to keep in mind. First, predicted outputs only works with the GPT-4o and GPT-4o mini models right now.
Okay, so not with all the models then. Got it. Any other limitations?
Like we talked about before, keeping track of cost is important.
Yeah.
You want to check that usage object in the response, see exactly how many tokens were accepted, how many were rejected. It's like a receipt for how many tokens you use.
Okay, so like tracking expenses but with tokens instead of dollars. Speaking of tokens, we've been saying that word a lot. For someone new to Python and AI, what are tokens exactly?
Right, good question. They're kind of like the fundamental building blocks of language, at least for the API. Think about when you write Python code, you break it up into individual lines.
Yeah, so each line is like an instruction or action.
Exactly. Tokens are kind of like that, but for language.
Okay.
Instead of whole words or sentences, the model breaks down the text into these smaller units, the tokens, which can be words, parts of words, even punctuation.
So it's like the model has its own way of parsing language, breaking it down into manageable pieces, kind of like how we break down a problem into smaller steps when we're coding.
Yeah, perfect analogy. And just like in Python, where efficient code is important, understanding how the model does that can help you write better prompts and keep costs down.
Makes sense. As I start working on more complex projects with the API, that'll be really useful.
Definitely.
Is there a way to actually see how it breaks down text into tokens, like before we even send a request?
Oh, yeah, for sure. They have a tool called the tokenizer. You can see how any text would be tokenized. It's like peeking into the model's thought process.
That's cool. So it's like a translator that shows us how the model sees the world. How does that tokenization even work, though? What's the magic behind it?
Well, the API uses something called byte pair encoding, BPE for short.
Okay.
It's a little technical, but basically it's an algorithm that looks for common patterns in the text and groups them together into those tokens.
So it's like the model is learning the structure of language by finding those patterns, kind of like how we write functions in Python to reuse blocks of code.
Exactly. It's all about patterns and making things efficient. Understanding that process can give you a real advantage when you're working with the API.
Okay, starting to get a better handle on tokens now. So once we know about tokens, what's next in our journey through the documentation?
We got to talk about how to actually communicate with the model, give it instructions, and get the output we want.
The art of talking to AI. I'm all ears.
It all comes down to writing good prompts.
Yeah.
That's your instruction to the model, telling it what you want it to do. The documentation has a ton of info on how to do that effectively.
So there's a strategy to it, not just random text.
Okay.
It's like writing a good Python program, clear, concise, the right instructions.
Exactly. Just like how we use functions and loops and stuff in Python to control the program, we can use different techniques with prompts to guide the model.
So what are some of those techniques that we can find in the documentation?
There's a few key ones. You've got zero-shot prompting, where you just give it the tag without any examples, like, hey, summarize this article.
Okay.
Then there's few-shot prompting, where you give it a couple of examples to guide it, like showing it how to do something first.
So like giving someone a recipe versus showing them how to cook step by step.
Right. And then there's fine-tuning, where you train the model on specific data to tailor it to your needs.
Right.
The documentation goes deep on each of these, with examples and tips.
It's like we're learning a whole new language here, the language of AI. And the documentation's our phrase book.
Haha, I like that. And it's constantly being updated, too, as AI keeps advancing.
So it's like a living document, always evolving.
Yeah,
Super helpful for someone new to all this.
for sure. And speaking of evolving AI, there's another important thing to understand. The different models that the API offers.
The models, yes. I know there are different options, but I'm still not quite clear on how to choose the right one.
That's a great point. It's like choosing the right Python library for a project, right? You wouldn't use a library for web dev if you're doing data analysis.
Right, you got to pick the right tool for the job.
Exactly. It's the same with OpenAI models. They each have their own strengths, and the docs do a good job of explaining those.
Okay, so let's crack open this model toolbox. What should a Python beginner know about?
Well, you've probably heard of GPT-3, GPT 3.5, and now GPT-4, the big names.
Yeah, I've heard of those, but honestly, still a bit fuzzy on the differences. What are they, and what makes each one unique?
So GPT stands for Generative Pre-trained Transformer, kind of a mouthful, but basically they're these powerful language models trained on a massive amount of data.
Like feeding it tons of information, kind of how we'd import data into Python to analyze it.
Exactly. And because they've seen so much text, they can understand and generate human-like text in really amazing ways. It's like they learned the language through all that training.
That's wild. But I'm guessing each GPT model has its own specialties, right?
Absolutely.
Yeah.
GPT-3, for example, is known for its text generation. It can write stories, poems, articles, all sorts of things. GPT 3.5 builds on that with better reasoning and conversation skills.
Like it took some extra Python courses on logic and communication. And then there's GPT-4, the latest one. What makes it so special?
GPT-4 is even better at problem-solving, code generation, understanding complex instructions, and it can generate different creative text formats like poems, codes, scripts, musical pieces, you name it.
So each new GPT model is like a software update, always getting better.
That's a great way to put it. OpenAI keeps pushing the boundaries of what these models can do.
It's exciting, but also a bit daunting. As a Python beginner, how do we even know which GPT model to pick for a task?
That's where the documentation comes in. It has all the details about each model, the strengths, limitations, what they're best suited for. It's like a model matchmaking service.
So we're not just picking the newest model, we're thinking about what our project actually needs.
Exactly. The documentation helps you figure out your needs, compare the models, and pick the right one for the job.
This has been an awesome journey. We went from being a bit intimidated by the OpenAI documentation to understanding how to use it. We learned about tokens, prompts, different prompt techniques, and now the models. I feel like I have a much better grasp on things now.
That's great to hear. That was the whole point of this deep dive. Remember, the documentation is your guide, mentor, and playground.
I like that. It's not just a boring manual. It's a living resource that keeps up with this amazing technology.
Exactly. To everyone listening who's ready to start their own OpenAI journey, don't be afraid to experiment, ask questions, and see what you can do.
The documentation isn't a maze. It's a treasure map. Dive in, have fun, and see what amazing things you discover.
Couldn't have said it better myself. Thanks for joining us for this deep dive into OpenAI documentation.
Yeah, until next time, keep exploring, keep learning, and keep pushing the boundaries of what's possible with AI. All right, so let's dive in. Today we're going to tackle the OpenAI documentation and specifically this function calling thing
Ooh,
that
yeah.
they have.
I love it.
It's pretty neat.
Yeah.
But I know for our listeners, with about 3 months of Python under their belt,
Yeah,
it can be a little bit daunting going through all that technical stuff.
for sure.
So we're going to try to break it down,
Absolutely.
make it easy to understand.
Yeah, think of it like this. You're about to explore a brand new city,
Okay?
right? And you could just wander around and get lost.
Right.
But it's so much better if you have a tour guide.
Yeah, someone to point out all the landmarks and cool spots.
Exactly. We're going to be your guides for the OpenAI documentation.
Awesome. So let's start with the basics.
Okay.
What exactly is function calling? Like, I'm scrolling through the docs and I see this term and I'm like, whoa, what is that?
Okay, so function calling, it's all about giving those OpenAI models like extra abilities
Okay.
beyond just making text, like giving them tools. So imagine you've got like a database packed with customer info or an API that tells you the weather or even a system to send out emails.
Oh.
Function calling lets you teach the model to actually use these things.
Wow. So we're like connecting the AI to the real world.
Exactly.
That's pretty cool.
It opens up a ton of possibilities.
So I was looking at the documentation you sent me.
Yeah.
And there's this example about getting the weather using a function.
Right.
But honestly, code can sometimes make my head spin.
Uh-huh. I get it.
Can we break down that example and like figure out what's going on under the hood?
Absolutely. Let's demystify it.
Okay.
That getWeather function is a fantastic starting point.
Okay.
It's basically a set of instructions written in Python
Okay.
that teaches the model how to fetch the current temperature
Got it.
for a specific location.
Mhm.
And here's the cool part. You don't need to be a geography expert
Okay.
to use it. The model can usually figure out the latitude and longitude.
Wait, hold on.
Yeah.
If the model can figure out the coordinates itself,
Right.
why even bother giving them in the function?
That's a great question, and it brings up a really important point.
Okay.
You see, while these OpenAI models are getting super smart,
Yeah.
there's still a lot of value in giving them structured information.
Okay.
So by being specific, like giving the latitude and longitude,
Okay.
we give the model a clear roadmap,
Yeah.
right? It makes sure things are accurate, and it reduces any chance of the model misunderstanding what we want.
So it's like we're helping the AI out, even if it could technically figure things out on its own.
Yeah, it's like giving it the best possible tools to do its job.
Okay, that makes sense. I like the roadmap analogy.
It's all about clarity and precision in the world of coding.
Right. Especially when we're dealing with AI.
Absolutely.
Okay, so we've got our getWeather function written in Python.
Right.
We're giving the model specific input like location coordinates.
Okay.
But how does this function calling thing actually work?
Good question.
Like, what are the steps?
It's a bit like a dance. A 4-part dance between your code and the OpenAI model.
Okay, I like where this is going.
All right, so first you call the model with your defined function.
Okay, so we're handing the AI the instructions.
Exactly. It's like giving it the blueprint.
Got it.
What happens next?
Okay, so next, the model takes a look at your request.
Yeah.
And it decides, hey, do I actually need to use this function or not?
So it's not just blindly doing everything we tell it to do.
It's getting smarter all the time.
It's thinking for itself.
It's using its intelligence to figure out if the function is necessary.
That's pretty cool.
Right. Then if it decides it needs the function,
Yeah.
it moves on to step 3,
Okay.
which is executing the function.
Uh-huh.
So this is where your code steps in and does the actual work,
Okay.
like fetching the weather data in our example.
So our code is like the worker bee,
Yeah.
and the AI is the brains of the operation.
I like that analogy.
Okay, so what's the final step?
Okay, so the last step is sending the results back to the model.
Okay.
So in our weather example...
Yeah, this would be that temperature reading.
Okay.
The model then takes that temperature and uses it to give you the final answer.
So it's like the AI is saying, okay, I checked the weather using your instructions and here's what I found.
Exactly. It's a team effort.
This is making so much more sense now.
Good. I'm glad.
But I'm curious, is there anything special we need to do when we're defining these functions? Or is it just like writing regular Python code?
That's where things get even more interesting.
Ah,
We don't just write any old Python code.
okay.
We give the AI some extra structure using something called a schema.
A schema. Okay, I'm getting flashbacks to my database class.
Haha. It's a bit different here, but the idea is similar.
Okay, how does a schema fit into this whole function calling thing?
Think of a schema like a menu at a restaurant.
Okay, a menu.
Yeah, it tells the AI what dishes are available, what ingredients it needs,
Okay.
and a little description to help it choose the right one.
Okay, so we're giving the AI a menu of options to choose from.
Exactly.
And-
And this helps it understand what we want it to do.
What kind of information goes into this schema?
Okay, so there are 3 main parts.
Okay.
First, you have the name of the function, which is pretty straightforward.
Okay, makes sense.
Then there's a description,
Yep.
which helps the AI understand what the function does and when to use it.
Okay.
And finally, we define the parameters.
Parameters.
Yeah, those essential inputs the function needs.
Okay.
This is where it gets a bit more technical because we use something called JSON schema to define those parameters.
JSON schema. Okay, I remember hearing about that. It's a way to like define the structure of data, right?
You got it.
Okay.
It lets us specify not just the types of data, but also any rules or constraints.
So it's like setting clear expectations for the AI.
Exactly.
Okay, got it.
Yeah,
We're making sure the AI uses our functions correctly.
absolutely. That structure is key when working with AI.
Okay, so we're starting to get a handle on how to define these functions and like package them up neatly for the AI. But are there any other like best practices we should keep in mind to make sure the AI really gets what we're trying to do?
Oh, absolutely. There are some key things that can make a huge difference. So when it comes to writing those instructions for the AI, you always want to be clear and concise.
Right. Treat it like you're explaining things to a new team member. You
Yeah.
know, make sure they have all the information they need.
Exactly. You want to make sure those function descriptions are super clear.
Okay. Any tips for doing that?
Absolutely. Imagine you're writing a user manual,
All right.
but for someone who takes everything literally,
No. Okay.
you got to be explicit, avoid any jargon,
Yeah.
and use real examples.
Got it. No room for ambiguity.
Nope, got to be precise.
Okay, but how picky is the AI really?
Yeah.
Do we need to write like a novel for every single parameter?
Haha. Thankfully, no, it's not about writing War and Peace for each one.
Okay, good.
It's all about finding that balance between clarity and being concise. You know?
Right.
And remember those tokens we talked about?
Oh yeah, the units of text.
Exactly. They actually matter when it comes to cost and efficiency.
Right. Too many tokens and things can get expensive.
Or slow down.
Okay, so we want to be clear, but also like mindful of the cost.
Exactly. It's like writing a tweet. You have a limited space to get your point across.
Perfect analogy.
Yeah.
Okay, so the documentation also mentions something about using the system prompt to guide the AI.
Yes. The system prompt.
What is that all about?
It's like giving the AI some background information before it starts the task,
Okay,
like setting the stage.
got it.
You can use it to give high-level instructions or even hints about which functions are relevant.
So we're like giving the AI a bit of direction before it starts making decisions.
Exactly, helping it stay focused and on track.
Okay, I like that.
Yeah.
So we've talked about being clear with our instructions using the system prompt.
Yeah.
But there's also this idea of like offloading the burden from the model.
Yes, offloading the burden.
What does that mean exactly?
Okay, so it's about being strategic
Okay.
with which tasks we give to the AI and which ones we handle ourselves. Like if we already have some information like user preferences or order details,
Yeah.
we shouldn't make the model try to figure it out.
Right, just give it what it needs.
Well, we can just give it to the AI directly.
Okay, that makes sense. Be efficient.
Exactly. Streamline the process.
So it's all about finding the right balance
Yeah,
between what the human does and what the AI does.
exactly. A good collaboration.
Okay, so the documentation also suggests keeping the number of functions manageable.
Right.
Something like less than 20 at a time.
Yeah, fewer than 20 for optimal performance.
Okay, why is that? Is it a technical thing or just a good practice?
It's kind of both.
Okay.
If you have too many functions, it can overload the model,
Yeah,
and that can slow things down or even make the results less accurate.
right. We don't want to confuse the AI.
Exactly. Keep things focused and organized.
But what if we really need more than 20 functions?
Well, in that case, OpenAI has some more advanced techniques like fine-tuning.
Tuning.
Yeah, where
Yeah.
you can train the model on your specific set of functions.
Yeah. So it becomes an expert in those tasks.
Exactly.
Okay, cool. Now I also noticed something called hosted tools in the documentation.
Oh, yes, hosted tools.
What are those?
Think of them as pre-built functions provided by OpenAI.
Okay.
They handle those common tasks like searching files or getting data.
So we don't have to write them ourselves.
Exactly. They save you a ton of time and effort.
That's awesome. But when would we use a hosted tool versus making our own custom function?
Good question. It depends on the task.
Okay.
If it's a common thing and there's a hosted tool for it,
Yeah.
then using that tool is usually the best way to go.
Okay.
But if you need something super specific that's tailored to your app,
Yeah.
then you'll want to build your own custom function.
Got it. Choose the right tool for the job.
Exactly.
Okay, so let's go back to that scenario where the AI needs to make multiple function calls.
Okay, multi-step tasks.
We talked about it before,
Right?
but I think it would be helpful to see a concrete example.
Absolutely. Let's make it real.
Hmm.
Imagine you're building an app that helps people plan trips.
Okay, I like it.
You might need to call functions to get the weather forecast for different places, book flights, reserve a rental car.
Right, so we're stringing together a bunch of different tasks,
Yeah.
each handled by a different function.
Exactly.
How does the AI manage all of that?
Okay, so the model's response would include a list of tool calls,
Okay,
each with its own ID and the arguments it needs.
okay,
Your code would then go through those calls one by one.
like a to-do list.
Exactly.
Okay, so it's like the AI saying, first check the weather in Paris, then book a flight to Rome,
Mhm.
and finally reserve a car in Barcelona.
You got it. And your code is like the personal assistant making it all happen.
And for each task, our code has to like understand the arguments, run the function, and then send the results back to the AI.
Exactly. It's a well-coordinated workflow.
That's amazing.
Yeah.
But the results that we send back to the AI,
Yeah,
they have to be formatted as strings, right?
that's right. Everything needs to be a string.
Okay, why is that?
It's like having a common language that both the AI and your code can understand.
So they can communicate effectively.
Exactly.
But the format of the string itself,
Yeah,
that can vary depending on what we're trying to convey, right?
absolutely. You can use JSON plaintext, even error codes,
Okay.
as long as it's a string.
So it's all about clear communication, even when we're dealing with different types of data.
Precisely. And the AI is smart enough to interpret it all.
Okay, so once all the functions are done, we send the results back to the AI.
Exactly. And the AI takes it from there.
And that's how we get this seamless integration between AI and the real world.
That's the magic of function calling.
This is blowing my mind. We're giving the AI a toolbox and teaching it how to use those tools.
I love it. You're getting it.
And remember those extra configuration options we talked about.
Oh, yeah.
Tool choice, parallel function calling, and strict mode,
They give us even more control.
or like fine-tuning knobs for our AI.
Exactly. You can decide how much freedom the AI has or how strict it needs to be.
Okay, so we've covered a lot of ground here.
We have.
Function schemas, best practices, multiple function calls, hosted tools.
It's a lot to take in.
But I think we're starting to get a good grasp of this whole function calling thing.
I agree. You're doing great.
Now, are there any other key areas we need to explore to really complete the picture?
Oh, yeah. There are a few more things that are essential for mastering function calling.
All right, so what else can we learn about function calling?
Okay, let's talk about streaming function calls. Remember we mentioned watching the AI think in real time?
Oh yeah, it sounded really cool.
It's like getting a behind-the-scenes look at how the AI is working.
So instead of waiting for the whole process to finish, we get updates as it's happening.
Exactly. Imagine you've got a request that involves multiple function calls. Streaming lets you see which functions the AI is choosing, how it's filling in the arguments, even getting partial results along the way.
So it's not just a black box anymore. It's more like a glass box.
Haha, I like that. Technically, it works by sending these chunks of data called deltas.
Deltas. Okay, what's in those?
Each delta tells you about what the AI is doing at that moment, like which function is being called, its ID, even the arguments as they get filled in.
So it's like a live stream of the AI's thought process.
Pretty much. And this is super helpful for debugging.
Yeah, I can see that.
Yeah.
But I'm guessing there's some coding involved to actually capture and understand these deltas.
You're right, it's not automatic. You need to write code that can receive those deltas as they come in and then extract the information.
Okay, so it's like building a custom decoder ring for the AI.
Exactly. You're decoding the AI's language.
So besides debugging, are there any real-world uses for streaming?
Oh, absolutely. Think about building a chatbot. With streaming, you can make the conversation much more natural and responsive. As the AI is figuring things out, it can send back partial messages or even start taking actions before it's done thinking.
So no more awkward pauses while the user waits. It's like a real conversation.
Exactly. Another great use case is for those long-running tasks. Streaming lets you monitor the progress in real time, like a progress bar for AI.
Okay, so we can see what the AI is up to. That's really helpful.
Right. It gives you more insight into the process. Now, one thing that I think is really important is error handling.
Oh yeah, error handling. It's like the not-so-fun part of coding.
It's easy to get caught up in all the cool things that AI can do, but we need to be prepared for when things go wrong.
Right, like when the network is down or the data is messed up.
Exactly. The real world is full of unexpected things, and our code needs to be able to handle them.
So it's not just about writing code for the happy path.
No, we have to think about those bumps in the road and tell the AI what to do.
Like having a backup plan.
Exactly. The documentation talks about designing functions to handle errors gracefully and give meaningful error messages.
So instead of just saying, oops, something broke, we can give more specific information.
Right. Which makes it much easier to fix things.
Okay, error handling check. Anything else we should know?
I think we've covered the essentials. Remember, this is just the beginning of your OpenAI journey.
Right. We've just scratched the surface.
The documentation is a treasure trove of information.
And now we have the tools to navigate it.
Exactly. So don't be afraid to dive in, experiment, and see what you can create.
Who knows what amazing things you'll build. Thanks for joining us on this deep dive into the OpenAI documentation.
It was a pleasure.
Until next time, happy coding, everyone. All right, so you're diving into OpenAI docs and you're like 3 months into Python. Awesome. You've made a really cool choice. But let's be honest, those docs can be a little intimidating, right?
Yeah, for sure.
But don't worry, we're going to map it out together so you can really get in there and start building some awesome stuff.
Exactly. And the cool thing is, 3 months into Python, you've got the basics down.
Yeah.
It's just a matter of bridging that to how OpenAI structures things.
Right. Okay, so before we get into the nitty-gritty, I was looking through these docs the other day, and, they've got this real-time API. And did you know this thing uses GPT-4o
Oh, yeah.
and GPT-4o Mini? Like, that is where the action is.
That's where it's at. That's the bleeding edge of everything. And the cool thing about the real-time API is the fact that they're focused on low latency and multimodal.
Oh, yeah, that's right. So it's a totally different game than some of the other stuff they've got.
Totally different. Think voice assistants, think real-time chatbots, think interactive experiences where things are happening right as you're engaging with them.
Whoa. Okay, so let's break this down for our listeners who are just starting out, right? Multimodal, what does that even mean?
Yeah, so you're not just typing in text and getting text back. You can actually use audio. You can have it speak back to you. It's AI that you can have a conversation with.
It's like talking to the computer.
Exactly. Exactly. Like in Star Trek.
Yeah. So how does that work technically? I mean, I know we're not getting into the weeds here,
Yeah,
but...
well, they use things like WebRTC, WebSockets.
Okay.
Again, we're not going to dive deep on that today, but those are the ways that you can actually connect to this API and make it work.
Got it. Okay, so another thing that stood out to me looking at the Python SDK,
Yes.
it specifically says beta support, which is honestly kind of exciting.
That is a good thing.
Yeah.
Means that they are actively working on it. They're listening to feedback.
Constantly improving it.
Yeah, for beginners, this is great.
Yeah.
It's only going to get better from here.
Awesome. Okay, so SDK.
Yeah.
That stands for what again?
Software Development Kit. And what that means is it's like a toolkit specifically for Python developers that make it easier to talk to the OpenAI API.
So instead of me having to write like a million lines of code,
Exactly.
it's like they give me some pre-built stuff, right?
They give you the building blocks, the functions, the tools. All you got to do is kind of put them together like Legos.
Oh, that's a good analogy. I like that. Okay, so let's say I'm ready to get started. Where do I go in this documentation? It's massive.
You're going to go to the section that says Get Started with the Realtime API.
Oh.
And they actually have this cool thing called the Realtime Console demo.
Yes. That's what I was going to say.
It's like a sandbox. You don't even have to write any code.
You can just like play around.
Yeah, you can send prompts, you can get responses. It's a way to really get your hands dirty before you even have to commit anything to code.
That's awesome.
Yeah.
Now, there's also, I saw this thing, a client-side tool calling example, and it had like a whole YouTube tutorial with it.
Yeah, they really hold your hand through this stuff.
Yeah. So for someone like me who learns best by like seeing things visually and seeing an actual example of it in action, that's huge.
Huge. Especially as a beginner, you need that kind of guidance, and they provide it.
Yeah. Okay. So partner integrations. This is another thing that caught my eye. LiveKit, Twilio, Agora.
Okay, so these might sound like kind of like strange companies.
They're kind of like buzzwords.
But what they are, they're companies that are making the real-time API work with, let's say, video calls,
Right.
phone systems, any kind of communication platform you can think of.
So it's not just like this standalone tool. It actually plugs into all the other stuff I might be using already.
Exactly. This is where the power of OpenAI really comes in, is that it's not just like a toy you play with. You can actually build real-world applications, integrate it with existing technologies, and it just opens up the possibilities. Especially for someone learning Python, this is where it gets really exciting.
Right. I can just imagine all the cool things I could build. Okay, so all of this sounds amazing, but I also need to know about, the practical stuff. Authentication, API keys, all that jazz.
You got it.
Yeah.
So authentication, that's how OpenAI knows it's really you making the requests. And they do this through these things called API keys.
Okay.
Think of it like a unique password that identifies you and allows you to access the API.
Got it.
And they walk you through exactly how to get your API key, how to manage it securely. All of that's in the documentation.
What about error handling? Like what if I screw something up?
They got you covered. The documentation goes through how to catch and handle errors gracefully so your application doesn't just crash if something unexpected happens.
Okay.
And they teach you about the different types of errors,
Yeah.
what they mean, how to respond to them. It's all there.
Okay. That's a relief. So to summarize, we've talked about how OpenAI works at a basic level. We've talked about this super cool real-time API, the Python SDK that's there to like make our lives easier, and then some of the more practical considerations. Did I miss anything?
I think you got it all. Just remember, when you're going through this documentation, it's a journey. It's not a race.
Yeah.
Take your time, experiment. Don't be afraid to break things. Try things out. And if you get stuck, the OpenAI community is amazing.
So helpful.
There are tons of resources out there. People want to see you succeed.
That's awesome. And don't forget, you can find links to all those resources that we talked about down in the episode description below.
Exactly.
Thanks for joining us on this deep dive and happy coding.
See ya.
Bye.
Bye.
Welcome to our deep dive. Today, we're going to be tackling something pretty cool.
Yeah.
The OpenAI documentation
Right.
for the real-time API.
Okay.
Now, before you think, whoa, too technical, we're going to break this down specifically for you, someone with about 3 months of Python experience under their belt.
Yeah.
Think of it like building a mental roadmap before you even think about writing
Yeah.
a single line of code.
Exactly. And knowing how to navigate documentation is a superpower in itself, especially with something like the real-time API,
Right.
which lets you build real-time applications using OpenAI's models.
Okay, so real-time applications.
Yeah.
What comes to mind for you when you hear that?
For me.
For our listener, what kind of things could they actually build with this API?
So real-time applications, I think about things that require like instant back and forth communication. So you think about like interactive chatbots that respond like you're having a conversation, or applications that react to things like live audio input.
Ah, so like a voice assistant
Exactly.
that you can actually chat with naturally instead of just barking commands at it.
Exactly. That's the kind of thing that the real-time API is perfect for.
Okay.
And one of the reasons that it can handle those variable connection states,
Yes.
think spotty Wi-Fi,
Yeah.
is because it relies on a technology called WebRTC.
WebRTC. You ever come across that?
I've heard of it, but honestly, it sounds a bit intimidating.
Okay.
Is it something our listener with their Python background
No.
needs to be a total expert in?
Not at all.
Okay.
It's more about understanding the role it plays.
Okay.
Imagine WebRTC like a direct line between your application,
Mm-hmm.
which might be running in a web browser,
Yeah.
and the OpenAI Realtime API.
Okay.
It handles all the complexities of real-time communication behind the scenes.
So kind of like a super efficient postal service
Yeah.
that makes sure your messages get delivered instantly, even if there are a few roadblocks along the way.
That's a great analogy.
Okay, good. And WebRTC is particularly important for this API
Yeah.
because it's the recommended way to connect from places like web browsers where security can be a bit more tricky.
Speaking of security,
Yeah.
the documentation mentions these things called ephemeral keys.
Yes,
They sound kind of mysterious.
you do.
Are we talking about some kind of secret code?
They are a kind of secret code,
Okay.
but temporary ones.
Okay.
Imagine using your standard API key,
Right.
which is like your master password right there in your browser.
Right in the browser.
That's like leaving your house key under the doormat.
Yeah.
Not very secure.
Yikes.
Yeah.
You're right. Not a good idea.
No.
So these ephemeral keys are like temporary guest passes.
Yeah,
You get one for a specific visit, and it expires quickly.
right.
So even if someone gets their hands on it, they can't do much damage.
That's the idea.
Right.
They add an extra layer of security specifically for real-time connections. The documentation emphasizes how important they are when you're building applications that run in a user's browser.
Yeah, that makes sense.
Right.
So it sounds like these ephemeral keys are essential.
They are.
But how do they actually work in practice?
It's a three-step process.
Okay.
First, your browser sends a request to your server asking for a temporary key.
So even though we're talking about building applications that run in a browser,
Mm-hmm.
we still need a server involved somewhere.
Yes. You need a server-side environment that you control to manage these keys securely.
Okay.
Think of it as your key master. It has the master key and gives out temporary ones as needed.
Our secure key master.
Right.
What happens next?
The server then takes your standard API key, which should be kept super safe on the server,
Right.
and uses it to request an ephemeral key from OpenAI.
Okay.
Then that temporary key is sent back to the browser.
And finally, the browser can use that temporary key to connect to the real-time API safely.
Exactly. It's like a relay race where the temporary key is passed from the server to the browser to establish that secure connection.
So we've got our secure connection. We understand about the ephemeral keys.
Right.
What's next? How do we actually connect to the API?
Okay.
What are those essential details that the documentation highlights?
All right, so you'll need the specific URL,
Okay.
https://api.opni.com/v1 realtime.
Right.
Think of it as the address you need to send your request to.
Okay, the address.
And then you'll use what are called query parameters.
Query parameters.
These are like little instructions added to the URL to customize your connection.
So like if I'm ordering a pizza,
Right.
I might add a query parameter to specify extra cheese.
Exactly.
Okay.
In this case, you might use the model parameter to specify which OpenAI model you want to use.
Okay.
Like GPT-4 Real-Time Preview 2024-12-17 if you want to work with GPT-4.
Okay, custom pizza, custom AI model.
Exactly.
What else is important for this connection setup?
The authorization header, this is where you include that ephemeral key we talked about, basically proving you have permission to access the API.
Right, like showing your ticket at the door.
Exactly.
Got it. So we've got the address, the customization,
Right.
and the ticket makes sense. Now, I know there's a code example in the documentation.
Yeah.
Is that something our listeners should try to understand line by line right now?
Don't worry about memorizing every detail.
Okay.
Let's just look at the key parts
Okay.
to get a feel for the structure. The example uses JavaScript,
Okay.
but the concepts are similar no matter what language you're using.
All right, so a high-level flyover of the code. What are the main landmarks we should see?
First, you see the code fetching that ephemeral key from your server,
Yeah.
like we discussed. Then it sets up the WebRTC connection, which is like establishing the communication channel.
Okay.
The code also handles things like audio input and output.
Okay.
Since we're talking about real-time applications, often involving voice.
So someone could actually speak into their microphone, and the model could respond back with its own generated audio.
Exactly. That's the magic of the real-time API.
Wow.
Then the code creates a data channel.
Okay. A data channel.
Think of this as a dedicated lane on that communication highway, specifically for sending instructions to the model and receiving its responses.
So like a VIP lane for the
Exactly.
important messages.
Exactly. And finally, it initiates the session, which
Okay.
is like opening the door for the real-time exchange to begin.
Wow, so there's a lot going on behind the scenes.
There is.
But it sounds like for our listener, the key takeaway here is understanding the general flow rather than memorizing every line of code.
You got it. It's about seeing how the pieces fit together.
Right.
Now, we briefly touched on creating those ephemeral keys on the server side,
Right.
that crucial keymaster role.
Yeah.
Want to quickly recap how that works?
Yes, definitely. I imagine that might seem like a whole other beast to someone who's still new to web development.
It can feel that way, but it's a pretty
Right.
standard process. Basically, your server uses your secure standard API key to request a temporary key from OpenAI
Right.
and sends it back to the browser.
Okay.
The documentation has all the details on how to set this up.
Okay, so it sounds like our listener doesn't need to become a server-side expert overnight,
No.
but they should know that this process is happening behind the scenes.
Exactly.
Okay, good. Now let's get to the really fun part, sending instructions to the model and getting those responses back. This is where the real magic happens.
Right?
All right, hit me with it. How do we actually talk to this AI through the real-time API?
Remember that data channel?
The data channel.
It's essentially a two-way street.
Okay.
You send instructions to the model by packaging them as events,
Events.
which are like messages sent over this channel.
Okay.
And the model sends back its responses in the same way also as events.
So it's a constant back and forth with each side sending these structured messages through the data channel.
Exactly. Think of it like a really efficient conversation, with each message clearly labeled and understood.
Right.
The documentation even gives a great example of sending a simple request.
Okay.
Say you want the model to write a haiku.
Right.
You would create an event with the instructions there, write a haiku about learning Python, and send it off.
And then the model would hopefully send back a masterpiece of Python-inspired poetry.
Fingers crossed.
Yeah.
But this really illustrates the power of interacting with the model dynamically.
Right.
You can build entire conversations,
Yeah.
adapt to the responses in real time,
Wow.
and it's all thanks to this structured communication system.
Wow, that's amazing. It's almost like having a creative partner who can generate text, audio, and even execute code based on your instructions.
It can.
So for our listener, what's the one key thing they should take away from all this?
The power is in understanding how this communication works.
Okay.
The real-time API has a specific language, a set of rules for talking to the model and getting results back once you grasp that the possibilities are endless.
This is all so incredibly fascinating.
It is.
But I imagine it can feel a bit overwhelming at first.
Right.
What's the best way for our listener to approach the rest of the documentation without getting lost in the details?
You're right. It's a lot to take in. Don't try to absorb everything at once.
Yeah.
Just focus on one concept at a time.
Okay.
Start with the example code. Play around with it and see if you can make it do something cool.
Right.
And remember, the OpenAI community is a great resource.
Yeah.
There are lots of people out there willing to help you on your journey.
It's so comforting knowing you're not alone when you're learning something new, especially in the world of AI, where everything seems to be moving at warp speed.
Exactly. So we've covered a lot of ground in this first part.
We have.
WebRTC ephemeral keys even got a sneak peek at the code.
It's like we've given our listener a treasure map.
Yeah.
And now it's time for them to start exploring what adventures await them in part 2 of our deep dive.
In part 2, we'll dive even deeper into the real-world possibilities of the real-time API. We'll talk about different types of applications you can be, the power of sessions and conversations, and how to integrate external tools to make your applications even more powerful.
Buckle up!
So buckle up, the journey's just begun.
I love it. Welcome back to our deep dive into OpenAI's real-time API.
Yeah.
In part 1, we talked about the essential building blocks, WebRTC, those mysterious ephemeral keys,
Right.
and even got a glimpse of the code.
Yeah.
I'm ready to see what we can actually build with all of this.
Okay.
What are some of the exciting possibilities the documentation highlights?
This is where it gets really fun. We've been hinting at it.
Okay.
The real-time API is all about building applications that can have real-time conversations, and the documentation highlights just how powerful that can be.
I'm picturing things like those super smart chatbots that everyone's talking about, the ones that can actually hold a conversation and sound almost human.
Right.
Is that the kind of thing our listener with their Python skills could realistically aim for?
Absolutely. And it all starts with understanding how the API handles audio.
Yeah.
Remember WebRTC, that direct line we talked about? With
Yes.
WebRTC, you can capture audio from the user's microphone and send it directly to the model for processing.
So I could literally talk to my application like, hey, AI,
Yeah.
write me a poem about a cat wearing a hat,
Right.
and the model would actually understand what I'm saying.
That's the idea. And what's even cooler is that the model can send back audio responses as well.
Oh, wow.
It's not just limited to text.
So it could actually talk back to me. Now, that's what I call a real-time conversation. It's like having a little AI friend right there on my computer.
Yeah.
But I imagine it takes more than just sending audio back and forth
Right.
to build something like that.
You're absolutely right. Building a conversational AI is like building a house. You need a solid structure. That's where the concept of sessions comes in.
Sessions, okay.
A session is basically a container for your interaction with the real-time API.
So if we're sticking with the house analogy,
Yeah.
is a session like the foundation that everything else is built on?
That's a great way to put it.
Okay, good.
Within a session, you can manage the flow of the conversation. You can send all kinds of instructions to the model, not just audio.
Okay,
You can send text prompts,
right.
make function calls,
Yeah.
and even interrupt the model if you need to.
Hold on, interrupt the model. Is that like saying, hold on, I need to clarify something in the middle of a conversation with a person?
Exactly. It gives you that level of control over the interaction.
I see.
You can guide the conversation,
Hmm.
provide feedback,
Yeah?
and make sure the model stays on track.
Okay.
And the documentation even talks about this function calling feature.
Function calling.
What do you think that means?
Function call. Well, in my limited Python experience,
Right.
functions are like little blocks of code
Mm-hmm.
that do specific things.
Yeah.
So is this about getting the model to run those functions? Like, could I have a function that looks up the weather
Okay.
and then have the model tell me the forecast?
You got it. Function calling lets you connect external tools and services into your real-time applications. Imagine you're building that voice-controlled travel planner we talked about.
Okay.
You could use function calling to connect the model to a flight booking API.
So when I say book me a flight to Paris next week,
Yeah.
the model could actually go out and book that flight for me. That's incredible.
It really is. You're essentially giving the model access to the real world. It can understand your request, pull in information from external sources, and even take actions on your behalf.
Okay, now my mind is officially blown.
Yeah.
This is starting to feel less like simple coding and more like building a whole universe inside my computer. But I have to admit, even with all these amazing examples, it can still feel overwhelming.
Right.
What's the best way for our listener who's still relatively new to this to avoid getting lost in all the details?
You're right. It's a lot to take in. But the key is to break it down into bite-sized pieces. Don't try to learn everything at once. Focus on one concept at a time, like sessions or function calling experiment. With the code, examples in the documentation, start small and gradually build your understanding.
That's such great advice, and I imagine the OpenAI community can be a great resource for help and inspiration along the way.
Absolutely.
It's always comforting knowing you're not alone in this.
And speaking of community, one of the most valuable things the documentation does is show you how to build things in a safe and responsible way. They talk about best practices for security and how to make sure you're using the API ethically.
Ah, so it's not just about the technical stuff.
No.
It's also about being a good AI citizen. That's really important. So we've talked about a lot of really cool possibilities in this part, from building chatbots to integrating external tools.
Yeah.
What's the one thing you'd want our listener to walk away with?
The possibilities of the real-time API are really only limited by your imagination. The documentation gives you the tools and the knowledge, but it's up to you to take those tools and build something amazing.
That's such an inspiring message. And on that note, what awaits us in the final part of our deep dive? What's the last piece of the puzzle we need to explore?
In part 3, we'll get even more hands-on and dive into the specifics of how data is sent and received through the real-time API.
Okay.
We'll look at the different types of events, those messages we've been talking about, and see how you can use them to build those dynamic interactive applications.
Awesome.
So stay tuned. The most exciting part is yet to come.
Welcome back to the final part of our deep dive into OpenAI's real-time API. We've covered a lot of ground, from the foundations of WebRTC and ephemeral keys
Yeah.
to exploring the exciting potential of sessions and function calling.
Right. It's been quite a journey.
It has, but now it's time to get into the nitty-gritty
Okay.
of how real-time communication actually happens.
Right.
We talked about sending instructions to the model and getting responses back. Now let's see how that works under the hood.
Okay. Sounds good.
Okay, time to roll up our sleeves and get technical. I'm ready to dive into the nuts and bolts. Where do we start?
So remember that data channel we keep mentioning,
Yeah.
the one established through WebRTC?
Yeah.
That's the heart of the operation.
Right.
It's like a dedicated communication line between your application and the OpenAI model.
So it's more than just streaming audio back and forth like we talked about with voice assistants. We
Right.
can send any kind of data through this channel.
You got it. And the way we do that is through these things called events.
Events.
Think of them like structured messages that travel back and forth along the data channel.
Okay.
You send instructions to the model as events, and the model sends its responses back in the same way.
So instead of just a jumbled mess of data, it's a series of organized messages,
Right.
each one with a specific purpose and meaning.
Exactly. It's like having a well-defined language for talking to the model.
Okay.
This structure is what makes it possible to build really reliable and predictable real-time applications. Now, the documentation gives a great example of using events to ask the model to write a haiku. Remember that?
Yes, I loved that example. It really painted a picture of what's possible.
Yeah.
Could you walk us through how that actually works using this event system?
Absolutely. So first, you'd need to create an event to send to the model.
Right.
Each event has a type, which is like a label that tells the model what kind of message it is.
Okay, a label. Okay.
For example, to ask for a response, you might use the event type response.create.
Okay, so the event type sets the stage for what's coming next.
Yeah.
What else would this event need to include?
It would also need the actual instruction for the model, in this case, something like write a haiku about learning to code.
Yeah.
That's the core of your request.
And then this nicely packaged event gets sent off to the model through the data channel.
Exactly. The model receives the event, processes the instruction, and then sends its response back as another event.
Okay.
This response event would likely have a type like response.content, indicating that it contains the generated output.
So we've got this elegant back and forth happening.
Yeah.
An instruction event goes out, a content event comes back with the model's response. It's all starting to click into place.
Yeah.
But I'm guessing there are more event types than just those two, right?
Oh, absolutely. There's a whole vocabulary of event types to cover different scenarios. You have events for sending and receiving, audio monitoring the conversation, flow handling errors, and much more. The documentation provides a comprehensive list, so you can pick and choose the right ones for your specific application.
It's like having a toolkit full of different communication tools.
Exactly.
And I bet those events can carry more than just simple text instructions.
You're right. Events can include additional parameters to fine-tune the model's behavior. For example, you might specify the desired length of a response, the format you want the output in, or even something called temperature, which controls how creative or predictable the model's output is.
So it's like adding extra instructions to your message, giving you even finer control over the conversation. It really highlights the flexibility of this API. For our listener who's eager to start building, what's the key takeaway they should have about this event system?
It's all about understanding this language of events.
Okay.
Once you grasp the concept of event types and parameters, you can start to see how you can build all sorts of dynamic interactions.
This has been such an incredible deep dive. We've explored the technical underpinnings, the potential for amazing real-time applications, and now we've even gone deep into how that communication with the model actually works as we wrap up. What are your final words of wisdom for our listener as they set off on their own adventures with the real-time API?
I think the most important thing is to approach it with curiosity and in a willingness to experiment.
Yeah.
Don't be afraid to jump into the documentation, play with the code examples, and try building something, even if it's just a simple proof of concept.
Right.
The more you explore, the more comfortable you'll become with this powerful technology.
I couldn't agree more. The world of real-time AI is vast and full of possibilities, and the real-time API provides a gateway to explore those possibilities.
Exactly.
Yeah.
So go forth, experiment, build, and who knows, maybe you'll be the one to create the next groundbreaking real-time application that changes the world.
That's a fantastic note to end on. Until next time, keep exploring, keep learning, and we'll catch you on our next deep dive. All right, so you're about 3 months into learning Python,
Okay.
and you're ready to really start exploring the magic of OpenAI.
Right.
But maybe taking that first look at the OpenAI documentation.
Yeah,
You're feeling a little intimidated.
for sure.
I get it. I totally get it.
It's a lot.
My first glance at it, I was like, whoa.
It can be overwhelming.
But that's exactly why we're doing this deep dive together.
Absolutely.
We're going to break down those key concepts, really build a roadmap
Yeah.
so you feel super confident when you actually go to tackle those docs.
Kind of like having a guide for a new city.
Oh, I like that.
You know, you want to know the landmarks before you set off exploring on your own.
Perfect analogy.
Okay.
And speaking of landmarks, the first thing that jumps out at me
Okay.
in the documentation is this real-time API with WebSockets section.
Right.
Now, I know a little bit about APIs, but WebSockets, I
Mm.
mean, those are like high-tech socks or something.
Huh?
Just kidding. But seriously, what's the deal with those?
Okay, so imagine you're on a video call.
Okay.
You and the other person are constantly sending and receiving information
Right.
back and forth,
Yeah.
right? That's kind of how WebSockets work.
Okay.
They create this continuous two-way connection for real-time communication,
I see.
which is perfect for like an AI chatbot where you want those instant responses.
Okay, so instead of sending like a separate message every single time,
Exactly.
it's like a constant open line.
Yep.
That's pretty cool, especially for something interactive.
Yeah.
But why wouldn't you always use WebSockets then?
That's a great question. WebSockets are fantastic for server-to-server communication.
Okay.
So like your server talking to OpenAI servers.
Mhm.
But if you're building something for users that are on web browsers
Right.
or mobile apps, they actually recommend using something on WebRTC,
WebRTC.
which is a whole other deep dive
Yeah.
for another time. But just know there are different tools for different situations.
Got it. Adding that to my list of things to learn about.
Good idea.
So back to WebSockets and OpenAI for now. The documentation mentions using your standard API key for authentication,
Right.
as long as it's on a secure server, of course.
Of course.
They seem pretty serious about security.
Oh, absolutely. And rightfully so.
Yeah.
You're interacting with a powerful AI.
Right.
And your API key is essentially your access pass.
Like a house key.
Exactly like your house key.
You wouldn't just leave that out in the open.
Yep.
So we've got the why of WebSockets.
Okay.
What about the how?
All right.
Like, how do we actually plug in this awesome technology?
Well, the documentation actually gives you the specific URL,
Okay.
wss.api.openai.com/v1 realtime.
Hmm.
It's like the address you type into your browser,
Right.
but for your code to connect to the OpenAI service.
Gotcha.
And then you also need to specify which AI model you want to use.
Okay.
It's kind of like choosing the brain power for your project.
Ah, so that's where we pick which AI we're going to chat with.
Exactly.
What about those headers I see mentioned?
Uh-huh.
Authorization and OpenAI beta. Do those have something to do with my hat collection?
Not quite haha. Think of headers like extra information attached to your request.
Mm-hmm.
The authorization header is where you put your API key.
I see.
It basically proves it's really you,
Right.
and you have permission to use the service.
Okay.
As for that OpenAI beta header,
Yeah, what's that about?
that's just a little flag that's needed because,
Sure.
well, we're still in the beta testing phase.
Makes sense.
Things could change, so it's
Right.
kind of their way of saying, hold on tight, we're still perfecting this.
Beta phase.
Yeah.
Always exciting
Yeah.
and a little nerve-wracking.
That's true.
Okay, so let's say I've got my WebSocket connection all set up.
Right.
API key tucked away safely in a header.
Securely.
Then what?
Then what?
How do I actually talk to the AI?
That's where things get really interesting. The key is understanding how to send and receive events.
Okay.
It's like the language you use to communicate with the AI.
Ooh, AI language.
Yeah.
I like it.
That's what we'll dive into next.
Can't wait.
All right, so let's talk about these events.
Okay.
Think of it like you're texting back and forth with a friend. You send a message.
Okay.
They receive it.
Ah,
Think about it for a second and then send one back.
okay.
In this case, your friend is the OpenAI model.
Gotcha.
And those messages that you're sending back and forth, those are called events.
Events.
They're the building blocks of your real-time interaction.
Okay, so what kind of messages are we actually talking about here?
Sure.
Like, can I send a text prompt as an event?
Exactly. You can send different types of events,
Okay.
and text prompts are definitely one of them.
Okay.
You can also send instructions
Yeah.
to kind of control how the AI responds.
So it's not just about getting information back.
Right.
It's about, like, shaping how the AI gives it to me.
Yeah, exactly.
Wow, that's pretty powerful.
It is.
So how do I know, like, what kind of instructions I can actually give?
Yeah, that's a good question.
It's not like I can just be like, do a backflip,
Right, huh?
and it's going to magically happen.
Well, that's where the API reference comes in.
The API
Within the documentation.
Okay.
Think of it like a dictionary
Okay.
for all the different events that you can send and receive.
Got it.
It'll tell you the format, what parameters you need.
Right,
It
but-
even gives you some helpful example.
Okay, so the API reference, that's like my cheat sheet.
Exactly.
I'm definitely bookmarking that one.
Good idea.
Okay, so let's go back to that texting with a friend analogy.
Yeah, okay.
If I send a text prompt as an event,
Right.
what happens next? Does the AI just like immediately text back with a response?
It's a little more structured than that.
Okay.
Remember, we're dealing with code here.
Right.
So the AI receives your event first.
Okay.
It processes it, and then it sends back its own event.
Its own event.
Yeah, and that event might contain the response you're looking for,
Okay.
but it also might just be like a status update.
Oh.
Or even a request for more information from you.
Oh, so it's not just like one back and forth.
Right.
It could be an entire conversation
Exactly.
with multiple events going back and forth.
Yeah, like a little chat.
Okay. I'm guessing this is where things could get a little more complex.
Yeah, it can get a little tricky.
Especially if we're dealing with like different types of data, like audio or images or something like that.
Absolutely. And that's why the documentation has entire sections on real-time model capabilities and the event API reference. They go into a lot more detail there.
Gotcha.
They talk about managing conversations, handling different types of data, all sorts of really advanced features.
So like the next level stuff.
Exactly. But for now, just focus on grasping that core concept of events being the messages that are driving your interaction with the AI.
Events are like the language of the AI. I got it.
Perfect.
So we've covered WebSockets for the connection. Events for communication. But I've got to be honest. This is all still pretty abstract.
Yeah.
I could practically hear our listeners out there thinking, okay, cool concepts, but how do I actually put this into practice?
I hear you. And that's the perfect segue to our next point, code examples.
Yes.
The documentation actually provides these little snippets of code in different languages to show you exactly how to implement these concepts in a real-world scenario.
So something like having a recipe.
It's like a recipe, exactly.
To follow.
Yeah.
As you're cooking up your AI-powered application.
Okay, so code examples, finally, something I can really sink my teeth into.
I knew you'd like that part.
I do, but I have a confession to make.
Oh.
My Python's getting better. But my knowledge of other languages is pretty limited at this point. So am I even going to be able to understand these code examples?
Yeah, that's a valid concern.
And it's actually something the documentation addresses really well.
Okay, good.
They do provide examples in Node.js and browser-based JavaScript alongside Python, but they really focus on illustrating those underlying concepts that apply across all the different languages. It's like learning the basic grammar rules that work for any language, even if the specific words might be a little different.
Okay, so even if I don't know every single line of code in a Node.js example, I can still get the big picture and see how it connects back to what we've been talking about.
Exactly. The goal isn't to become fluent in every single programming language out there. It's to understand those core principles of how to interact with the OpenAI API.
Gotcha.
The code examples are really just there to illustrate those principles, not to overwhelm you with a bunch of syntax.
I appreciate that. That makes a lot of sense. So we've talked about high-level concepts like WebSockets and events. We've touched on the practical side with these code examples. What else should we highlight for our listener before we wrap up?
Well, I think it's important to emphasize that the OpenAI documentation, it's like a map. It might seem kind of daunting and overwhelming at first glance. But once you understand the key landmarks and the language of the map, you can navigate it with confidence.
Ooh. I love that analogy.
Nice.
Because it really captures that feeling of going from lost in the woods to, hey, I can actually read this map now.
Exactly. And with the knowledge we've covered today, our listener is going to be well equipped to approach the documentation with that same sense of confidence.
Absolutely. So to recap, we've talked about WebSockets being so important for that real-time communication.
Yes.
We talked about this concept of events as the language of interacting with the AI.
Yes.
And how those code examples can really help bring those concepts to life.
Yeah.
How are you feeling? Feeling more prepared to tackle those docs now?
I think so.
Me too.
I definitely am.
I'm confident you are.
Awesome.
And remember, the documentation is your friend. Not your foe. With a little guidance and the right mindset, you can unlock the full potential of the OpenAI API.
I love that. And on that encouraging note,
yes,
let's wrap up this deep dive.
Sounds good.
Thanks for joining us and happy coding.
All right, so we've covered a ton of ground in this deep dive into the OpenAI documentation.
Yeah, we really have.
We talked about WebSockets being that always-on connection,
Yeah.
events being the language we use to talk with the AI.
The language of AI.
I love it.
Yeah.
And even how to use those code examples as a guide.
Those are super helpful.
They are, and I feel like I've leveled up my understanding just from this conversation alone.
That's awesome.
It is. But before we officially send our listener off on their AI adventures, let's do a super quick recap.
Right.
What are the absolute must-knows for someone just starting out
Okay, good question.
with the OpenAI API?
Okay, so first and foremost,
Yeah.
you've got to embrace the fact that WebSockets are your friends.
Yes.
They're the foundation for real-time communication.
Like constant back and forth.
Exactly,
Totally.
with the OpenAI models.
And it's not just about knowing what they are.
Right,
It's about understanding why they're so important
exactly.
for this kind of interactive experience.
Yeah, back and forth, yeah.
Exactly.
So then once you're comfortable with those WebSockets,
Yeah.
you need to understand how to actually establish that connection.
Okay, so how do we do that?
Well, you've got to use the correct URL, of course.
Right.
Make sure you have those all-important headers for authentication.
Super important.
Here. And, of course, specify which AI model you want to use.
It's like getting your passport stamped and your boarding pass ready
I like that.
before you even step foot on the plane.
Yeah, a good way to think about it.
Right. All right, so we've got that connection set up.
All right, we're ready to go.
We're in the world of OpenAI.
We've landed.
What's next?
Then it's all about mastering the art of communication
Okay.
through events.
Yeah.
Remember, those events are those messages
They are.
that are driving the interaction.
Back and forth
Yes, exactly.
with the AI.
Right.
And our API reference is like our trusty phrase book
Exactly.
for this new language.
It's your go-to guide to really understanding
Yes.
the structure and the parameters and the possibilities.
and many possibilities
I know, it's exciting.
of each event.
So WebSockets for the connection.
Check.
Events for communication.
Check.
API reference as our translator.
Got it.
You got it.
Okay. But what about those code examples?
Yes.
I know they can be a little intimidating at first glance,
I know, especially
especially for someone who's
Yeah.
still relatively new to coding.
Just still learning, yeah.
So what do we do? How do we approach those?
That's where it's important to kind of shift your perspective a little bit.
Okay.
Don't think of them as like tests that you need to pass.
Right.
Think of them more as helpful guides to
Right.
really illustrate the concepts that we've been discussing.
Even if I don't understand every single line.
Even if you don't,
Yeah.
focus on that big picture.
Okay.
How do those examples demonstrate the interaction
Right.
between your code and the AI?
Because the documentation does a good job of giving us examples in different languages.
It does, and it really highlights those universal concepts
Yeah.
that apply regardless of which language you're using.
Okay, so it's really about those core principles.
Exactly.
Not getting bogged down by the specifics
Not at all.
of one particular language.
Yeah.
Okay, so for our listener out there,
Okay.
who's getting ready to dive into the OpenAI documentation,
Yes.
what is the one piece of advice
Ooh, good question.
we want to leave them with
The one piece of advice.
from this entire deep dive?
Don't be afraid to explore. The documentation might seem a little daunting at first.
Right.
But remember, you now have the tools and the knowledge.
We've given them the tools
You've got them.
to navigate it with confidence.
You do so think of it as an exciting adventure.
Ooh, I love that.
Not a tedious chore.
An adventure.
An adventure.
All about embracing that journey
It is.
of learning and discovery.
It really is.
I love it. And hey,
Yeah.
if you ever get lost,
Yeah,
that's what we're here for.
that's what we're here for.
Another deep dive, perhaps.
Always happy to help guide the way.
Awesome. Well, on that note,
Yes,
it's time to wrap up this deep dive.
let's do it.
Thanks for joining us, everyone, and happy coding. All right, everyone get ready, because today we are going deep into the OpenAI documentation, and specifically for the Realtime API.
Yeah, it's going to be fun.
And we're going to try to tailor this, to our listeners, kind of assuming that they have, about 3 months of Python experience under their belts.
That's right, 3 months.
And they are ready to unlock the magic of real-time AI.
That's right. And, think of us as your guides
Yeah.
through the documentation because the official documentation can be a bit intimidating.
Yeah.
For sure. So we're going to give you a lay of the land, a mental map before you even open up those docs so you don't have that deer in the headlights look.
Exactly. And that's, what we want to do is really make sure that you can approach that documentation with confidence, not confusion.
That's right.
So let's just start at the very beginning. Big picture. What is the real-time API and why is it so cool?
So the Realtime API lets you build applications that have a real-time back-and-forth conversation with an OpenAI model. So that means you can have things like voice assistants, chatbots, all sorts of really cool things that are much more interactive.
So it's more dynamic than just, I send a prompt and I get a single response back.
Exactly.
Okay, I see.
Much more dynamic.
And so I'm assuming there's different ways to actually connect to this API.
Yeah, so there's two main ways to connect,
Okay.
WebRTC and WebSockets.
Okay.
So WebRTC is really great if you're working in a web browser because it uses the browser APIs
Gotcha.
to send the audio back and forth, and it's really specifically designed for this real-time streaming.
Okay.
Now, WebSockets are a bit more versatile. You can use them for a wider range of applications,
Okay.
but they do require a little bit more setup on your end, a little bit more coding.
Okay, so we've got those two paths.
Yeah.
But before we even choose one, we need to talk about the foundation of the real-time API, which is sessions.
Yes.
What are those and why do we need them?
So a real-time session is a dedicated connection between your application and the OpenAI model. It's a stateful connection, so it can last for up to 30 minutes. And what that means is it remembers the entire conversation.
Okay.
Everything that you said, everything the model said, it remembers it.
So it's not starting from scratch each time. It's building on what's already happened.
Exactly.
Yeah.
Exactly. So it's really creating this conversational experience.
That makes sense.
Yeah, and there's a few key components to a real-time session. The first is the session object.
Okay.
This is kind of like your control panel.
Okay.
So you can choose which model you're using. You can customize things like the voice that the model will use to respond.
So if I wanted to build something with a specific personality, I could choose the right model for that vibe.
Exactly. So it's about finding the right tool for the job.
Okay.
Then we have the conversation. Think of this like a transcript.
Gotcha.
Everything that's been said both by you and the model.
So kind of a behind-the-scenes chat log.
Right, exactly.
Okay.
And then we have responses. These are the outputs that you get back from the model. Okay.
And they can be text or audio or even both.
Oh, wow. Both at the same time.
That's right. Yeah. So you can have multimodal applications.
Okay. That's really interesting. Yeah. And then finally, we have the input audio buffer. And this is really specifically for WebSocket connections.
Okay.
And this is a temporary storage for the audio data that's streaming in. And it allows the model time to process that audio.
So it's kind of like a holding tank.
Exactly.
While it figures out what to do.
Yeah, exactly.
Okay. So we've got our session and we've got our model. We've got the conversation log. We've got the way to handle audio.
Yeah.
If we're using WebSockets, how do we know? How does the application know when it's connected and when it's ready to go?
Right. So when you first connect, the API will send you a session.created event.
Okay.
And you can think of this as a digital handshake.
Okay.
Saying, hey, we're connected, we're ready to go.
All right, so we're good to go? We can start sending information over to the AI model. But what if we need to change something mid-session? Like, we decide we want to use a different model or tweak a setting or two. How do we do that?
Right. So for that, we have session.update.
Okay.
And this allows you to make changes to the session on the fly.
That's really useful.
Yeah, so you don't have to start a brand new session. You can just update it.
Okay, that makes sense.
And it's very flexible in that way.
Cool. So we're not stuck with our initial choices. We can adapt.
Exactly.
Okay, cool. Cool. So now we've kind of got the basics of a session down. Let's talk about how we actually interact with the model. So how do we send text and receive, those brilliant responses?
Right. So to send text, you use an event called conversation.item.create.
Okay.
And this is basically like you're adding your input to that conversation log.
Okay, so it's like sending a message in a chat app, but we're doing it through code.
Right, exactly.
Okay.
And then to trigger the model's response, you use response.create.
Gotcha.
So you say, hey, I've given you some input. Now it's your turn to respond.
Now, and this is where I think things get really interesting. The documentation mentions that if both audio and text are enabled, the model can actually respond with both.
That's right. Yeah.
It's like we're having a conversation with a real person.
Exactly.
Wow, that's really cool.
And so as the model is working, you'll actually receive a series of events to keep you updated on its progress.
Okay.
So one of those events is response.text.delta, and that will give you snippets of the text response as it's being generated.
So we're not just waiting for the final output. We're getting real-time feedback.
Exactly.
Right.
Okay, that's useful.
So you can show that to the user. You can update your interface.
Yeah, definitely a more dynamic, responsive experience.
Exactly.
Okay, cool. And then once the model is done and it's finished its response, it's going to send a different event, right?
That's right. You'll get a response.done event.
Yeah.
And this tells you the response is ready to be used. Okay, great. And that makes sense. We've covered a lot of ground here. Sessions, events, text input and output. But I feel like we're just scratching the surface here.
Right.
Text is just one part of the equation. What about real-time audio? That's where things get really futuristic.
You're right. That is where things get really exciting. And that's actually what we'll be diving into next.
Awesome. Can't wait.
So the Realtime API can actually handle audio directly, which I think is a huge game changer.
Yeah.
You don't need separate speech-to-text or text-to-speech tools. It's all built in.
It really opens up the possibilities for, apps that can truly understand and respond to your voice.
Yeah, exactly. It's a whole new level of interaction.
It's super exciting. But before we get too carried away, dreaming up voice-controlled robots, let's break down how the API actually handles this audio.
Okay, sure.
We talked about WebRTC and WebSockets before.
Yeah.
So how do they fit into the picture?
Yeah, so they're the two main ways you can connect to the API for audio streaming. And WebRTC is the simpler option, especially for web-based applications, because it just uses your browser's built-in APIs
Gotcha.
for handling the audio.
So it's kind of like plug in a microphone and let the browser do the heavy lifting.
Yeah, exactly. You just use a simple command called getUserMedia
Right?
to access the user's microphone, and then the API takes care of sending that audio stream to the AI model.
Pretty seamless.
It's really seamless.
Okay, so
Yeah.
WebRTC sounds like the easy choice for getting started.
Yeah.
But what about WebSockets?
So WebSockets give you a lot more control over the audio data.
Okay.
Instead of just sending a continuous stream, you can break it down into smaller chunks,
Okay.
and you can handle each chunk individually.
So it's more manual,
It is more manual.
but maybe more powerful if you need that control.
Yeah, exactly, if you need that fine-grained control.
Can you give me an example of when you might need that?
Yeah, so let's say you're building a game, and the AI needs to respond to specific sound cues. With WebSockets, you could analyze each audio chunk as it's coming in, looking for those specific sounds.
So you're not just sending a raw audio stream.
Right.
You're actually like in the middle of it.
You're processing it in real time.
Okay, very cool.
Yeah. But of course, that comes with a little bit more complexity.
So you got to do a little bit more on your end.
Right. So you have to handle events like input.audio_buffer.append
Okay.
to send audio chunks to the server, and response.audio.delta to receive the audio chunks back from the AI model.
Okay, a little more hands-on,
It is a little more hands-on.
but it opens up a lot of possibilities.
Definitely.
But either way, whether we're using WebRTC or WebSockets,
Yeah.
how does the model know when to respond?
Right.
Is it just constantly listening and analyzing, or what's going on?
Yeah, so that's where voice activity detection, or VAD, comes in.
Yeah.
And this is a really cool feature.
EAD.
Yeah, VAD.
Okay.
So it intelligently analyzes the audio stream to determine when someone's speaking and when they've stopped speaking. So it knows, okay, now it's time to respond.
So it's like having an AI sound engineer
Exactly.
who's just, always paying attention,
Always paying attention.
making sure that the response happens at the right time.
Right. And you can even adjust the sensitivity of the VAD using a property called session.turn-detection.
Okay.
So you can make it more sensitive to quiet voices, or less sensitive so it only picks up louder speech.
Okay, so it's like fine-tuning a microphone.
Exactly.
Like at the right level of background noise or whatever.
Yeah, exactly.
Okay.
But what if you don't want the AI to respond automatically?
Okay.
What if you want to control it manually?
Why would you want to do that?
So, there are certain applications where you need that kind of deliberate control. Like, let's say you're building a push-to-talk interface
Okay.
where the AI only responds when a button is pressed.
Okay.
Or maybe you're building a game where the AI only reacts to specific sound triggers.
Okay.
So in those cases, you can actually disable VAD, and you can manually control when the model responds.
So it's all about picking the right tool for the right job.
Exactly.
Okay, so we've covered the foundational elements, sessions, events, text input and output, now audio.
Yeah,
I'm sure there's more to uncover, though.
there is.
What are some of the more advanced features that might surprise me?
So let's move beyond the basic conversation flow and talk about how you can really start to shape the way that the AI interacts with your application.
Okay.
So one thing that you can do is you can actually tell the model to generate responses that don't become part of the main conversation history.
Oh, that's interesting.
Yeah.
So it's like having a side conversation with the AI
Okay.
without cluttering up the main chat log.
Exactly. And the way you do that is by manipulating events.
Okay.
So you remember that response.create event we talked about?
Yeah.
There's a field in there called response.conversation, and you can set that to none.
Great.
And that tells the API, hey, I want this response, but I don't want it added to the transcript.
So it's like whispering a secret to the AI. But how do we keep track of these off-the-record responses then?
So that's where metadata comes in handy.
Okay.
Metadata allows you to attach additional information to events.
Got it.
So you can use it to tag these special responses and keep track of them.
It's like labeling your files,
Exactly.
so you can find them more easily later.
Right, exactly.
So, it's interesting we're talking about all this, and it's really showing how important organization is.
Yeah.
When you're dealing with such a powerful API,
Yeah.
it's not just about sending commands, it's about managing the flow of information.
Exactly.
So speaking of information, what about the context that the model uses
Yeah.
to generate its responses? Can we get that granular?
You have a lot of control over the context. You can
How?
actually reference specific items from the conversation history
Okay.
to tell the AI to focus on particular points or pieces of information.
So if the user brings up something from earlier,
Right.
I can be like, hey, AI, remember this part.
Exactly.
Okay.
And you do this using the input array in the response, create event.
Gotcha.
It's like saying, hey, remember this, use this to inform your next response.
Wow, that's really powerful.
It is.
It allows for much more, nuance
Yeah.
and, meaningful interactions.
Exactly.
But what if you want to completely reset the context?
You can do that too.
Wow.
You can actually remove all context and have the model respond just based on a given instruction.
So it's like hitting the reset button,
Exactly.
starting fresh.
Yeah.
So you can have different modes of conversation, like a deep contextual exchange.
Right.
Or you could just do immediate instruction-based interaction.
Exactly.
Wow. Okay.
And that kind of brings us to one of the most exciting features of the real-time API, which is function calling.
Oh, yeah, I've heard about this.
Yeah.
This is where it gets really crazy, right?
It does get a little crazy.
We're giving the AI access to our code.
Yeah, that's right.
That's so cool and a little bit scary.
It is powerful, but it's also surprisingly easy to use. So essentially, you define functions that the AI model can call,
Okay.
and those functions can do anything you can code.
So we're giving the AI a toolbox
Exactly.
of actions that it can use
Right.
to, solve problems.
Yeah, or complete tasks.
Or do whatever it needs to do.
Exactly.
Right.
So as the AI is analyzing the user's input, it can decide, do I need to call one of these functions
Gotcha.
to get more information
Okay.
or to perform some action?
So it's like the AI is saying, hey, I need help with this.
Right.
Can you run this code for me?
Exactly.
This is really blowing my mind.
It's a powerful feature.
Can we walk through like a concrete example
Sure.
to help me visualize this?
Yeah, so let's say you're building an app that has a weather feature.
Okay.
You could define a function called getWeather that takes a location as input and returns the current weather conditions.
Okay.
So let's say the user asks, what's the weather like in London?
Okay.
The AI model, being as smart as it is, recognizes that intent and says, oh, I need to get the weather for London.
Okay.
I need to call the getWeather function.
It's understanding not just the words, but like the meaning behind the words.
Exactly.
Wow.
So when it recognizes that it needs to call your function, it's going to send a response.done event.
Okay.
That includes a special function call item,
Okay.
and that function call item will have all the details that the AI needs to execute your code. So in this case, a location, London.
Okay. So our application is listening for this.
Right.
It sees this function call and it knows, okay, it's time to run my get weather code.
Exactly.
Bata is in London.
Right.
Get that weather information.
And then once you've retrieved the weather data from your code, you send the results back to the model using another event,
Okay.
conversation.item.create, with a type of function cal output.
So it's like we're having this little code-based side conversation.
Exactly.
It's asking for something we provided,
Right.
and then the conversation continues.
Yeah.
This is incredibly powerful stuff. But, with all this talk of code and events,
Yeah.
what happens when things go wrong?
That's a great question because no system is perfect,
Yeah,
and you need to be prepared for errors.
of course.
Of course, but the good news is the real-time API is designed to handle errors gracefully.
Okay.
It'll actually send you specific error events that provide details about what went wrong.
So it's not just silently failing.
It's not silently failing.
It's actually communicating with you,
Exactly.
which makes debugging a lot easier.
Yeah, and here's a pro tip. Use the evented field.
Okay.
So this is like a unique identifier for each event.
Okay.
And when you get an error, you can match the error as evented with the evented of the original event that caused it.
So it's like a breadcrumb trail
Exactly.
that
Yeah.
leads you back to where things went wrong.
Right.
Okay.
So for example, let's say you accidentally send an invalid event type.
Okay.
You're going to get an error back with that same evented.
Okay.
So you know, that's where I messed up.
So error handling isn't so scary after all.
It's not as scary as you might think.
We actually have tools to help us understand what's going on.
Exactly.
But I got to admit, with all this talk about, code events, error handling, I'm feeling a little overwhelmed.
I can understand that.
It's a lot to take in.
Yeah, we have covered a lot of ground.
Yeah.
But I think the main takeaway is that the Realtime API is built on a logical foundation.
Yeah.
And once you understand the core concepts, these individual features become a lot easier to grasp.
That's true.
Yeah.
You're right. And even though it's a lot newer, I'm actually feeling more excited than overwhelmed.
That's great.
I'm starting to see the possibilities.
Yeah.
And I'm excited to start building my own real-time AI applications.
That's the spirit. And that's what we're hoping to achieve with this deep dive.
Yeah.
It's not about memorizing every detail. It's about giving you that mental model,
Right.
that understanding of how everything fits together.
That roadmap.
Exactly.
So to our listener out there who's ready to dive in, what's the next step?
What advice would you give them?
I know our listener is ready to start building,
Yeah.
but what advice would you give them? Are there any resources or tools that you recommend?
Yeah, I would definitely say the official OpenAI documentation is your best friend.
Of course.
I know it can be a little bit intimidating at first, but it's really well written and it's very organized.
Yeah.
And now that you have this kind of foundational knowledge,
Yeah.
it's going to be much easier to digest.
It's like we've given them a decoder ring for the documentation.
Exactly.
Suddenly it's all going to make sense.
Yeah, and don't be afraid to jump into the code examples. Try things out. Experiment.
Yeah.
That's really how you learn.
Learning by doing.
Exactly.
That's the best way. And, you don't have to do this alone.
That's right.
There's a huge community of developers out there who are passionate about AI
Yeah,
and always willing to help.
absolutely.
Online forums, tutorials, open source projects.
Tons of resources.
There's a wealth of knowledge and support out there. So don't be afraid to ask questions and share your projects and learn from others.
Exactly. The AI community is very collaborative.
Yeah.
So, yeah, definitely reach out and ask questions.
Before we wrap up, I want to leave our listener with a little challenge.
Okay.
Think about a problem you face in your own work or your own life, or maybe just something you've always wished existed.
Yeah.
And ask yourself, how could I use the real-time API to build a solution?
That's a great question.
What kind of creative, interactive application could you bring to life?
Yeah, the possibilities are pretty much limitless.
Yeah.
It's really up to your imagination.
So we can't wait to see what you create.
Yeah, have fun with it.
And remember, the most important thing is to have fun.
That's right.
And, embrace the journey of learning and discovery.
Absolutely.
Keep experimenting, keep pushing the boundaries, and most importantly, never stop asking questions.
Couldn't have said it better myself.
All right, until next time, keep diving deep.